Hello, everyone. Welcome to the very first edition of React Day Bangalore, a conference spread over 2 days. We are very excited to host this for you, and we hope you enjoy this as much as we do. It's a good Friday to kick off this, and have a great start to the day. So we hope you have a lot to learn and a lot of fun.
Hey everyone, warm welcome to all of you. Just as Varsha said, it's a great day and even more wonderful to see so many of you joining us today. We are very honored, proud, and so happy to welcome everyone to the first ever edition of React Day Bangalore.
Just a quick introduction of ourselves. Uh, we have here with me my co-MC Vishwa Mehta. You can use Vish for short. She works in the developer relations team at Hasura and is usually found in her natural habitat, that is, reading the world's best minds. Her love for poetry runs deep, and she writes a little bit of that too. I mean, if you want to ask more about it, DM her on Twitter. She's asked me not to tell anyone, but here we are.
And I'm super honored to be emceeing this conference alongside my lovely and amazingly talented co MC, Varsha Saha. Varsha is a senior front end engineer at Flipkart who loves reading books just like me, and is a proud mother of a doggo and is a huge chai-holic. Please give her all the love and a big round of virtual applause in the chat, and you can reach out to her on Twitter. Now that we're all here, it's story time. So you must be wondering how React Day came together. The React Bangalore meetup has grown into a huge buzzing community of passionate people since its inception 6 years ago. The amazing team behind all the hard work has organized over 60 meetups all over Bangalore with more than 12,000 members now a part of the meetup. With the 10,000 members mark in the community, which by the way was me, and I'm not even kidding, we saw it fit to grow this into something bigger to give back to the community. Hence, we present to you React Day Bangalore 2021. Woohoo! And we couldn't bring our conference in person, but there's always a silver lining, right? So, with React Day being online this year, we were able to reach over 4,000 registrants and 30 speakers from all over the world. And we couldn't be more excited about that. So, over the 2 days of React Day, we have 22 insightful talks, 3 panel discussions on really important topics in the community, and 30 awesome speakers joining us all.
Let's talk a little more about the technical details of how this conference would work. We all know that this is a virtual setup and we are not able to meet each other physically. Yet we've tried to organize it in a way which is easier for you to kind of talk to our speakers, talk to each other, and be on the main stage at the same time. So here, wherever you are actually viewing us right now, we call it the main stage area, and you're already here. So there's no other thing that you need to do to listen to the talks and to actually gain some knowledge about it. We also have a sessions tab in the hop-in setup that you have right now. If you look carefully on the left-hand side panel, we have a sessions tab. So all our speakers, after their talks, will be present at the same time in parallel to the other talks that are going on. They'll be there on the session stage where you can actually talk to them. You can ask them questions about the talks because we won't be able to take any questions on the main stage. We started a parallel thread on the sessions part of this Hopin's platform. We also have an expo tab where you can learn more about our sponsors. They are the core part of this virtual conference that we are hosting, and we are hoping that you can connect with them as well.
And since no conference is complete without swag and goodies, we will be giving away a bunch of cool stuff. We've dedicated the hashtag TIL React Day in for all of you to share your learnings with us and everyone else on Twitter. Tweet at us at React Day in using the hashtag and share what you've learned today to participate in our giveaways. We'd also love to see all the fun screenshots that you take from your favorite moments from the conference with our speakers, MCs, and co participants. Use the hashtag FunReactDayIn to share your moments with us. And brownie points if you take good pictures of Arsha and I. Just kidding. But best entries will still win a lot of cool goodies. So, also, I heard that the awesome sponsors that we have are giving away some really cool stuff. They'll be hanging out in the expo tab. So, please don't forget to go check out the expo during the breaks. And to communicate any issues or to communicate any feedback that you might have for us, or just to show love and support for the event, please feel free to tag at React Day in your tweets, and our team will be right there with you.
Okay, let's thank our partners without whom this conference would not have been possible. Thank you so much to our partners for helping us in the event promotions. You might have seen quite a few giveaway tweets from them on Twitter. If not, please do check out Twitter. Please keep posting about React Day on Twitter and check out our hashtags as well. Our partners for this event today and tomorrow are DevFolio, JSLovers.com, React India, and Women Tech Makers. A very, very huge shout out to our sponsors as well. Sponsors, as I said, are the integral part of any conference, and we couldn't be more thankful for so many sponsors to join us and help us out in this. So huge shout out to all of them. Given that all of this is going virtually, we would like to thank all of them from the bottom of our heart for helping us out and making this event successful. Our sponsors for this event are Archimedes, Atlantis, Auth0, ClearTax, Geeky Ants, GoIBibo.com, Grow, Harness, Hasura, Disney Hotstar, Open House, Column, Razorpay, Swiggy, and Exactly. Thank you again so much for making this possible.
Talking about what makes an event successful and possible, our code of conduct is an absolutely integral part of the conference, and it's pivotal in helping us run the event smoothly and ensuring that all of you have a good, memorable, and comfortable experience with us. We do not condone any type of harmful, abusive, or inappropriate behavior in any shape or form. So please do make sure that while you're interacting with the speakers, MCs, co participants, panelists, or the attendees, please make sure that all your interactions are relevant and appropriate. If you notice any kind of harmful, abusive, or inappropriate behavior around you, feel free to DM us at React Day India for any issues. Apart from that, cozy up and enjoy the 2 days of the conference with us. Now I'll be handing over to my co MC Varsha, and she'll be taking the conference forward.
Coming to the main part of the day, we'll kickstart our talks, our very awesome talks. The speakers have worked very hard. We've all been rehearsing for quite a bit of time. So I hope that you enjoy it and there's something to learn for everyone here. Let me introduce to you our first speaker, Sudhanshu. He's a front-end architect at HackerRank, and today he'll talk about destructuring React. So please give a virtual round of applause for Sudhanshu.
Hello, everyone. Just let me. Yeah, my screen is visible, right? What's Kiran? Okay, so hello, everyone. Good morning to all. In this talk, we will destructure React and will unpack the internals of the engine which powers most of your web application or mobile application. So there is one disappointment for const lovers. I have used let everywhere. The reason behind that because internals can change. So just a bit of disclaimer there. About me, I'm Sudhanshu Yadav. I work at HackerRank as a front-end architect, and I have authored a library called Brahmos. It's similar to React. It has all the APIs of React, the current one and the future one, like concurrent mode, and it has its own implementation of fiber architecture. That can. Sorry. Uh, that kind of led me to this talk because I dig deep into the React internals. I have also authored a library called React Number Format, which gets around 1.5 million download per month, and I have open sourced other OSS tools. I'm also an internals fanatic. I love to dig on the internals of the library we use. And for the same, I organize a meetup group called the internals, where we have discussed the internals of a lot of libraries, React internals, React router internals, V8 engine internals, and a lot of there. So with that, we'll kick a start. So any one who have used React knows that there are three main parts you have to use in your application to make React working. The first one is a compiler, and the compiler does the job of transpiling your JSX into valid JavaScript syntax. You might be using Babel for transforming, or you might be using TypeScript. The React is inbuilt on TypeScript. And then there is a React library itself. So all the APIs you import from the React library from 17 plus, it also have the JSX runtime, which compilers compiles to. And then you have a renderer, which for a different platform, you have like for browser, you have a React DOM. For mobile application, you have a React Native. There is a VR renderer, there is a WebGL renderer, and a lot many more. So when you see the compiler, the main job of compiler is just to like transform your JSX into valid JavaScript syntax. So you write something, a component in JSX, and it will transform into JSX runtime. What it does is like it brings the element type as a first argument, and followed by the props as object. Now, the React library is where you import all the APIs from, and as I mentioned, like you also the runtime also comes from the React library. So React library in itself doesn't do a lot, but when you are rendering it, whenever you are rendering your component, the JSX method will be called, and it will return something called React element. So here, every node, every object is a React element, and it creates a tree of React element, which we call virtual DOM. And this is the key of React supporting multiple platforms. So this virtual DOM can be transformed into any native element in a DOM. In a browser, it can convert it to DOM elements. For mobile, it can convert to the Android or iOS elements. Now, we know that there is a two thing, React and its render. But the question is how React know about this render? Because React render can be anything. You can have React DOM, you can have a React Native, and more interestingly, like in one page itself, you can have multiple render in one application itself. And most of the APIs you import, like hooks, React component, you import directly from the React library. So the only place you use render is on the top level, where you do React.render, and it's just once. But we also know that all the heavy lifting is done by the render. For matter of fact, the React library itself is around 2.8 KB, and React DOM is around 39.4 KB. So we can see like most of the part is in React DOM. So the question is how all this React API talk to a renderer, because we are not importing render anywhere. We are just importing the React APIs. There should be some link between React and React DOM, and that link is basically React shared internals. It's an object which is globally exposed in React property, and it's a very interesting property. It's called secret internals do not use or you will be fired. So this property, React DOM or any renderer can use by just saying React dot this secret internals property. So when you look into React shared internals, there is one important property to look into, which is called React current owner. And React current owner is a singleton between your library and the renderer. So because in render it imports like it uses from React dot the React side internals. And whenever renderer is rendering your application, when it is processing a fiber, we'll come into fiber later, but whenever it is processing a fiber, it hooks that particular fiber to current property of a React current owner. And then React library gets the information of that current fiber while creating new element on that component. So that's how like any of the element will have the information about the component it's rendered from. So it will have a owner property, and owner property will basically be the component fiber. Now there is another property which you should look for is React current dispatcher. So as mentioned, most of the heavy lifting is happening on the render part. Even render owns the actual hooks implementation. So what you use on React is just the top level APIs, wrapper APIs, and nothing more than that. The actual implementation is on render. And what render does, like whenever you are processing a fiber, it attaches all the hooks list of not on the component, but all the hooks like a use state, use ref, use effect, all those hooks as a dispatcher, and it will add it on a current property of a React current dispatcher. And when you render a React component, when you call the render method, like the functional component, those hooks will internally call the renderer specific hook implementation from the current dispatcher. So you can see like the actual implementation all are on render. React is just passing all the information from React to render, and render is attaching hooking itself into React lifecycle. The another important thing render does is like it has something called a class component updater. And what it does, like whenever you create a new instance, whenever renderer create a new instance of a component, it attaches that class component updater to component instance in a updater property. And when you call the set state of your class component, it will internally call the renderer updater. So that's why like even the set state, all the things are happening on the render and not the React itself. Now, coming to render, there are two main parts of a render, reconciler and platform renderer. Reconciler is a kind of common between all the renders. So it's a third, it's a React library which they internally use, and renderer imports reconciler and write platform specific renders based on it. So talking about reconciler, but before that, like let's see how React finishes update. So React finishes update in two phases, render and commit phase. So basically in a render phase, what it does is like it renders your functional component or like a class component. It generates virtual DOM. It will compare the older virtual DOM to new virtual DOM, and it will figure out what is the minimum difference required. So all of this thing happens on a render phase, and in the commit phase, once it has a list of all the update it has to apply on actual DOM, it will commit all those changes on commit phase. And reconciler runs in a render phase. When and the main job of reconciler is to do the rendering part and compare your previous virtual DOM with the new virtual DOM and find the minimum changes required for the actual DOM. Now, earlier the reconciler was based on a recursive algorithm. Basically, it was called stack-based algorithm, in which what was happening, if you have a component tree, a hierarchy, it will render all the components recursively from parent to child, and it will create a virtual DOM and find the difference and then commit those changes. But The problem with that was, let's say, if you have some component which takes a lot of time to render, then it blocks the whole main thread. So probably if there is any high priority updates happening on your screen, probably some animation, or if you're clicking some element, it will not register that part. It will just like um, block your main thread. So they came up with another architecture called Fiverr, and it's a new architecture for reconciliation. Um, how Fiverr works is basically reconciler create a Fiverr. It's basically a unit of work in an object form, and it creates a Fiverr for processing each React element, and then it processes one Fiverr at a time. So it processes Fiverr and then yield to your browser. So browser can do its priority things, and then it comes back to your reconciler. And if there is any change on your Fiverr, it will tag that Fiverr. Reconciler will tag that Fiverr to have any updates or effects. Actually, in a React terms, everything is an effect. It can either be a component effect or a DOM effect. Now, the good part of reconciliation is that it can be paused in between, because you are processing only one Fiverr at a time. So you can pause in between and you can resume back when you don't have any high priority updates. And once like a React fonts all the changes required for actual DOM, it goes into commit phase. In commit phase, it will apply all the effects on the actual DOM. And the thing with the commit phase is like you can't pause it in between. It has to go on one go. The reason behind that is like if you do that, you'll have a partial UI or inconsistent UI. So the updating UI should be at one go. Now, let's see this by some example. Let's see like what happens during initial rendering. So let's consider you have an app component in which you are rendering div. Inside the div, you have a form element and another div element, and see what happens during initial render. I have also kept this whole code snippet on the top right, so you can refer it while we are talking about the Fiverr tree. So basically, it will create a host root. It's another special Fiverr which it creates, and it will attach that host root in your container element. Now, as we have passed the app component in React DOM.render, it will create a Fiverr for the app component, and it will add that as a children to the host root. And then it will go next, and it will process the app Fiverr. And because it's a component, it will render the app component. If it is a class component, the renderer will attach the updater in a component instance, so that like whenever you do set state, it knows which render to call. And for functional component, renderer will store all the hook information in Fiverr on a property called memoized state. Now let's see a little bit about Fiverr. So Fiverr is basically a linked list, and whatever you have used inside a functional component, you can have a multiple use state, multiple hooks. All of this will be stored as an object with the next property, and next property pointing to the next hook, and the second one pointing to the third hook. So in Fiverr, it will not keep a reference of all these hooks. It will just keep the reference of the first hook, and from that it can go to the another hooks by doing .next. And whenever there is an update in a new render cycle, it runs the hook calls against the previous list of the hooks, which is present in the Fiverr. And if there is a mismatch, it will throw error. So basically, hooks, you have to make sure like it is in same order. You can't change the order, and also you can't put it in a like a if condition or something. So in every render, the order and the number of hooks should remain same. Otherwise, this whole linked list will break. Now coming back to our render part. So um, like once it calls the render method, it will create the fibers for all the rendered element. So it will first start with the child element, which is basically the div here. It will create fiber for that. Then child for div is a form element and another div. And then for form element is a component. Div has another child, which is a normal text, which is a static string. So one thing to note here that for normal text string, if it is only node within element, like a div element or something, it will not create a new fiber for it. But if there are multiple things, like if you have a text node with a combination of some spans and all, then it will create a fiber for a text node as well. But if it has only one text node, then it will not create for the optimization purpose. Now it has created all the fibers. It will mark the F fiber to have some, it will tag the F fiber to have some updates. And any fiber holds link to its parent fiber in the return property, and its first children, not all the children, just the first children, and in the child property and the sibling reference. So whenever the current fiber is processed, it goes to its first child, if there are any. If there aren't any child are pending to be processed, it will go to it's the next sibling. And the reason it doesn't keep the reference of all children is basically it can go always go to the first child and then do dot sibling dot sibling. So it doesn't have to go there. Now it will process the div fiber, and it will take the div fiber to have some DOM effect because it has to be appended on DOM, and then it will go to the next fiber, which is a form element fiber. It will process that, and the form element is a component, so it will render it, and it will continue the same process for all of its descendants. And it will also tag the form element for having some updates, because it's a component, and there could be some use effect or something inside that. Then it will go to, once all the descendant of form elements are done, it will go to the sibling of form element, which is a div here. It will process that. And then it will tag the div fiber to have the DOM effects. And once it has marked all the, it has tagged all the elements, it will go into commit phase. And in commit phase, it will commit all the pending effects. Now, let's see what happens during updates. That was a rendering. What happens during the update? So for the same example, let's say internally you are calling set values from somewhere, maybe inside form element you are calling on change, and which is calling set value. Now, this will trigger the re-render of your app component. So let's see what happens then. So React stores the reference of your current fiber tree, which represent your current state of your DOM in a pointer called current tree. And we'll just name it as a current fiber tree. And whenever there is an update, it will create, instead of touching the actual current tree, it will create a new work in progress tree. And in work in progress tree, it will clone the host root, because no changes are there. And then it will clone the children, which is an app fiber here. And then it will process the app fiber. On the app fiber, we saw that, okay, there is some pending state because we called that set value. It will call, it will re-render the app component. And it will get the previous hook information from memoize state property I talked about, and it will call the hook again using the same memoize state. And once it is done, it will mark the app component to have a pending effect. Now it will match the rendered children of an app component with the current fiber tree. And let's see a little bit on how this matching happens. And that is basically called the VDOM diffing. So whenever there is an update, it compares the new rendered element with the previous rendered element. And basically the previous compares the new virtual DOM with the previous virtual DOM. And it does it one element by element. And if like for a particular element, if there is a match, then it will just clone that fiber from current tree to the work in progress tree. It will not do anything else. And if it doesn't match, which can happen in following condition, let's say the type of element is different. So if earlier you were using a div element, then you change it to a span. So the type change. It can happen same for a component. The reference of a component can change. And if the reference of component changes, so it will unmount the previous component or previous element, and it will mount the new one. The other case is where you have provided a key, and the key of your element changes. If that is not considered for any reason, it changes. It will treat the previous element and new element as separate element. Even though the type is same, it will treat it as a new element, and it will unmount the previous one and mount the new one. So you have to be very careful on deciding what the key. It should be like a consistent key throughout render. Now coming back to our render, so it will match the new rendered element with the current fiber tree. So it will start with the first element, which is a div here. It will match it because there is no change in type, neither there is a key. It will just clone that fiber from current to work in progress. Now it will process the div fiber and mark that complete, because there is nothing else left to do on that particular element. That DOM element is already added in, like that particular element is already added in DOM element, so nothing else left to do. So it will just mark it as a complete. And then it will match their children with the current tree. So on the form element itself, the type is same, there is no key difference. So it will just clone the form element and the div fiber as well. But on the form element, there is a change in a props. So earlier we had a different value, now we have different value. So it will assign the new props as a pending props on the fiber, and it will keep the old props as memoized props in the form element fiber. Then once it is done, it will go and process the next fiber, which is a form element here. And form element has some prop changes. So it will call render, like it will render the form element again. And it will also tag the form element for having any changes or effects there. And it will continue the same process for all of its descendants. And once all of those are done, it will go to its next sibling, the form element sibling, which is a div here. On the div itself, we see like there is no change. It's mostly static. So it will just mark that div as a complete because there is nothing to update. And once all the tree has been marked or tagged, it will go into commit phase. And in commit phase, it will run all the pending effects. And also in commit phase, it will assign the pending props to memoized props of the fiber. The reason for doing that is like now the pending prop has been implemented, and now it is basically going as a next memoized props, and it will delete the pending props. And once because now our work in progress tree was representing the correct state of a tree, which represents the actual DOM, and the older current tree was stale. So what it does, it switches the pointer of current and work in progress tree. So it will make the work in progress tree current because it was holding the new state, and it will make the a stale version of a currently as a work in progress. The reason behind that, like why it makes the current tree as a work in progress, is that like next time there is an update, it can reuse those objects. It doesn't have to create those object again and again. It can just reuse and just update some properties there. So it can save a lot of computation on the garbage collection. It can save some CPU at that part. This is also called double buffering, and mostly this is a very common practice on some gaming engines. I had a lot to discuss today. I have a lot to share, but we have limited time, so I'll end up with the flow of how the whole fiber thing happens, how the hooks work, and I'll also share some resources. So there is a very good video on the whole fiber architecture by Lynn Clark. I'll definitely recommend you to go through that. And Rodrigo Pombo also created his own version of a React, mostly for teaching purpose, and he has created a documentation site for it, which is very interactive in nature. I'll definitely recommend this as well for you to go and just go through all the documentation. And if you are interested that how the BrahMos implement all this API, how it implements the fiber architecture, you can also look into the source code of a BrahMos. You can also reach out to me if you want to know about the internals of the BrahMos. And we have hosted all of our past internals meetup discussions into the internals YouTube channel, so you can go and check that out as well. So with that, I like to end my talk. And one thing I want to say is learn internals and you'll be hired. That, thank you. Thanks for having me here. Thanks.
Thank you so much, Sudhanshu, for that very insightful talk. Most of the time, we are busy building features without getting into the inner details of how things work. And especially how you presented the last slide, I think that was awesome. We should all be knowing the internals because that's how we build our basic building blocks of how a library or a framework is built. And unless we know that, we're just building things without really without deep dive into how things are actually working. So thank you so much again for that very insightful talk. Moving on, our next talk of the day is by Ankita Masand. She's the principal engineer working at Trebo Hotels, and today she'll be talking about event delegation in React 17. So please give a virtual round of applause for Ankita Masand. But before Ankita comes on stage, I would again like to reiterate the fact that we are connecting you to the speakers via the sessions tab on your Hopin platform. So don't forget to connect with Sudhanshu anytime you want. If you have any questions regarding what he spoke about or any other thing that you would like to interact with him on, please do open the sessions tab and connect with him. He'll be available there while Ankita's talk is going on. And also, let's welcome Ankita on the stage.
Hi everyone, I'm Ankita Masand. I'm a principal front-end engineer at Trebo. I'm currently working on Trebo's SaaS product called Hotel Superhero. My work involves building and architecting different modules of front-end part for Hotel Superhero product. I also like to write blogs on React, GraphQL, JavaScript, and web-related concepts in general. I try to explain difficult concepts in simple and easy to understand language. Today, I'm going to talk about event delegation in React 17. Let me first tell you why I chose to talk on this topic. I was debugging an issue related to a stop propagation event, and I hopped onto an issue that was reported on React's GitHub repository. When I read further, I understood that event delegation is not working the way it should be, and there's going to be a fundamental change in the implementation of event delegation in the current version of React, and what it is going to be in the succeeding versions of React. This looked interesting to me because, and I thought that this could be a potential topic for the talk because of two reasons. First one, event delegation is a fundamental concept in JavaScript, and yet if you ask this to many front-end developers, it takes some time to digest the word delegation, and there is a good chance that you won't get the correct answer in the first go. Another, we use React in most of our projects, and I think it makes sense to understand about these, how these fundamental concepts like event delegation work in the library that you so often use. I'm going to talk on event delegation for the next 15 to 20 minutes. And I think it makes sense to first understand what event delegation is all about. Then we'll understand how event delegation works in React 16 and earlier versions, what was the problem with that implementation, and how it got solved in React 17. Let's get started. Event delegation, it is basically a pattern for handling events. So what you see on the screen are different types of events. For example, on click, on drag, on mouse enter, these are some of the mouse events. On submit, on input, these are some of the form events. There's a UI event called on scroll. On load and on errors are some of the image events. You can have hundreds of click handlers in your application. You can have thousands of submit handlers in your application. The way in which you handle these pool of events efficiently that doesn't impact the performance of your application is called as event delegation. Let's consider an example to understand more about it. So here you have a container, and this container has 10 cards. The requirement is it should, whenever you click on any card, it should display the number that is printed on the card. For example, if I click on card number 4, there should be an alert saying card number 4. If I click on card number 6, there should be an alert saying card number 6. One way to go about this problem is to attach on-click event handlers to all of these 10 cards. And when a particular card is clicked, its respective on-click event handler would be executed, and it will print the number for this card. So if you click on card number 4, it will execute the event handler for card number 4, and 4 would be printed. Another way to go about it is just to have single event handler for this common ancestor container instead of having event handlers for each of these cells. Let's understand this with the help of an example. I have a very simple function. I have a very simple component here called event delegation. Obviously, the UI doesn't look as nice as it was in the diagram, but bear with me. We are going to understand the fundamental concept. I have just one on-click handler which is attached to the table element. If you notice, there is no on-click handler on each of these table cells. There are 3 rows, and in each of these rows, there are 2 cells. If I click on any of these cells, it should print the number that is there on that cell. For example, if I click on cell number 2, I should get 2. If I click on cell number 4, I should get 4. Let's try and see what happens. If I click on cell number 3, it is printing TD3. If I click on cell number 2, it is printing TD2. Okay, it is working as expected, despite the event handler being on the table element. Why is it important? Why is it important to do event delegation in the first place? Why is it important, to have just one event handler at the root of the element? When you saw, we just had one event listener at the root table element. This helps in improving the performance of the application. We are going to see on the next slide how it actually helps in improving the performance of the application and what's wrong in attaching event handlers to all of the cells in the table. So can we attach on-click handlers for all the cells in the table? Let's again go back to a test which is on jsperf.com. Here, this is a test which has one div element with ID as container. There is one element with class as 1, and there are many elements with class as many. This is an HTML structure that we are going to test on. Now, I'm going to run 3 tests. The first test, attach click handler to just one element which is with a class 1. The second test attaches click handlers to all the many classes. The third one attaches click handler to just the parent container, and then that handler is bounded to all the many events. So in the third test, there are not going to be as many event handlers as the many classes. There's going to be just one event handler which is on the container, and that event will delegate to the target nodes whichever is clicked. If you see the performance after running these three tests, you will notice that this is the fastest among all, and this is the slowest. So this if you attach an event handler just on the parent and let that handler delegate event to all the children, it is more performant than the other approaches, because obviously there's going to be just one event listener and not too many. So what did we learn? We learned that if we bind an event to many elements, it is much slower, even if the event is of one single type. So in the example that we saw, the event was just of one single type, click. And the most performant way to bind an event to the parent and delegate it to the target nodes. Cool, let's move ahead. So now we saw that it is we should have an event listener at the parent node. But what there's an event listener only at the parent node. How do these events propagate from parent to the target? Let's find out. There are four important event phases in JavaScript. Event.none, it simply means that no event is being executed. There's a capturing phase, which means that handlers are executed while descending down the tree. So what happens is when you click anywhere on the document, event first flows from document to the target. It reaches the target node, and then it flows from target back to the document again. Where these event handlers are executed decides the phase of the event. For example, when event is traveling from document to target and your event handlers are executed in this direction from document to target, it means that event is getting executed in the capturing phase. It reaches target. Now if the event handlers are executed while going upwards, while bubbling upwards, then it is that your event handlers are being executed in the bubbling phase. So your event is going to travel from document to reach target, and then from target to document. Where your event handlers are being executed, that decides the phase of the event. Let's visualize this with the help of a diagram so that it is more clear. If you click anywhere here, the event will first, and there is an event listener at the document. So what will happen is event will flow from document to reach the target node. It will reach the target node, and then it will execute the event handler. For example, on click, which is there on the TD cell. Then it will move upwards to the document. If you are executing this event in bubbling phase, what it will do is it will direct first propagate to target, execute the event handler of TD cell. Then while moving upwards, it will execute the event handlers that are associated with each of these elements. So while moving upwards, it will execute the event handler for TD, then TR, then T-body, and then table. And if your event is being executed in the capturing phase, it will execute the event handlers for each of these elements while going down the tree. Let's see this with an example so that it is again more clear. I'm taking the similar example. There's one component, event delegation bubbling. And or the difference from the earlier example is just that I've added on click to table, T-body, TR, and TD. In the earlier example, there was on click only at table. So now we have to figure out the sequence of these events that are going to be executed in the bubbling phase. I'll just do one change. I'll execute event delegation bubbling now. Now let's see the sequence of events. So if I click on one, okay, it is working as expected. It first print the console statement that is on the table cell, then it moved upwards, print the console statement for row, and then it prints the console statement for body, and then it reached the table. So what happened was event traveled from document to target, but the event handlers were executed when the event was traveling back from target to the document node. That's how event bubbling works. Let's quickly take an example of capture as well. So here in capture, the only difference is you have to use on-click capture event in React. Let me change in the app so that we can see what happens in capture. If I click on cell number 1, Again, this is working as expected. So it first clicked the event handler of table, then it moved down, clicked there's an event handler of T body is being executed, event handler of T row is executed, and then the event handler of T cell is executed. These were the two fundamental phases in event delegation: bubbling and capture. So now we learned about event delegation and two important phases in which the events get executed. Let's look at an interesting example now. That is related to event listeners. So here, if you see the screenshot, there's a button element and there are two event listeners. There are two event listeners that are being added to the button element. Both are of type click. The first one, after the promise is resolved, prints P1 and it prints 1. The second one, once the promise is resolved, prints P2 and it prints console log 2. Now we have to guess the sequence of these statements. I'll move further and we'll see what executes first. The correct answer is 1. So this would be printed first, then P1 and 2 and P2. If you guessed 1, 2, P1 and P2, let's find out why your answer is incorrect. First, we'll understand that both the click event listeners, they would be registered against the button element. This is confirmed. Now, these event listeners, they execute. So between these event listeners, there is a phase when the call stack is empty. First event listener, first this console log would be printed, call stack would be empty. Let's visualize this to make it more clear. So there's a console log 1. Once this is done, you have an async queue which is empty. After this is printed, the event loop will pick up console log P1 from async queue, and the promise will be resolved, and that's why this will be printed. And then the another event listener would be recorded in the call stack. So why these are not synchronous? Why we don't have console log 1 and console log 2? Because there is an empty, because both of these events, they don't occur simultaneously. There would be an empty space in call stack, and once event loop recognizes that the call stack is empty, it directly it picks up a task from async queue and executes that. So that's why P1 would be printed, and then another event will come on the call stack which will print console log 2. After printing console log 2, it will resolve the promise of the second event. So this is what we saw, right? The call stack is empty between both of them. This is the main important point. And since the call stack is empty, promise P1 will be resolved first. Also, you should understand that promises resolve asynchronously, and they will only be resolved when your call stack is empty. And that opportunity is when your first event handler is executed. That's when the call stack is empty, and the event loop will pick up this particular promise to resolve it. If you're still not convinced, let's execute this example and find out ourselves. I have copied the same code here. This is a JavaScript code that I showed on the screenshot. Here, there are two event listeners, same. So what I'll do is, let me click on this button. It prints 1, P1, 2, and P2. So it prints 1, P1, 2, and P2. Okay, so we learned a lot about event delegation, two important phases, bubbling, capturing. We also saw an interesting example related to event listener. Now let's move on to how event delegation works in React. In React, there is a wrapper around default browser events, which is called as synthetic events. So every event that you see in React is an instance of class synthetic event. Synthetic event contains these all properties. So there are properties called as prevent default, stop propagation, cancelable, and these all properties are associated with this class synthetic event. Why does React have a common wrapper for these events? It is simply to maintain consistency between different browsers, because each of the browsers, Chrome, Firefox, Safari, they have different behavior related to events, and React doesn't. So we as developers don't have to handle these nitty-gritties of events based on different browsers. React does it on its own. If you write React code, you might have seen that you don't ever write document.add event listener. We used to do this while writing JavaScript and jQuery projects, but we don't do it in React. It is because React automatically attaches event listeners at the document node. And also one thing to notice, React follows event bubbling, which means the event handlers would be executed when the event is traveling from target to the parent node. So how this works in React 16 and the earlier versions, there's going to be one single instance of on click, on change, on blur, and many other events which are attached to the document node. There won't be any listener to any of these child elements. There's going to be just one listener on the document node. And now if you click on TD, event will flow from document to TD. It will execute the listener which is on TD. It will execute the on-click function which is written on 3D, and while moving upwards, it will execute the on-clicks for T-body, table, app, etc. By default, React follows bubbling phase. So events would be executed while moving from target to document. Now, this is all fine and good. So what were the issues with event delegation in React 16? Why it didn't work out? So there were many issues which were reported in larger React projects. One of the issues that was reported by the Atom editor was using two versions of React in nested React trees. So let's understand this with an example. On the screen, you see there are two boxes. There is one red outer box, there is one blue inner box. Red outer box is being rendered by a different version of React. Blue box is being rendered by a different version of React. So basically there are nested React trees. And if I click anywhere on the blue box, there's a click handler which should print inner on click. If I click anywhere on the red box, it should print outer on click. So from what we learned so far, if I click anywhere on the blue box, the sequence of a console should be inner on click and outer on click. Because it follows bubbling, so it should print on click for inner element, and then it should move upwards and print on click for the outer element. Let's figure out if it is actually working properly. It just printed inner on click. If I click anywhere outside, it printed outer on click. It is not printing outer on click. So what actually happened is there is somewhere stop propagation event written here in the outer tree, and that is stopping the event from reaching the window level. That is stopping the event from reaching the document level. So ideally, this tree would have expected that if a user clicks anywhere, my event would reach the window level, but that is not happening. Let's understand with a very simple example, which is in React 16. So what I have here is, let me quickly explain the HTML structure. I have a div ID, which is parent. I have a div ID child. Now, what I'm doing is app.js has a simple button. So this simple, when I click on a button, it will print button clicked. Okay. Now what I do is on parent, I'm doing stop propagation on parent. And I'm rendering the React tree on inside child. So I'm rendering the React tree inside this div. And I have event.stop propagation inside parent. Okay. If I click on this button, this is not printing button clicked. As a user, I would expect that my event would be printed. I'm not concerned about the outside world. I just want this. If I click on this button should be executed. And that is not happening because some other developer who is working on the other parts of React, they have done stop propagation to the outer element, and that's why somehow your events are not working. We can quickly check this out in React 17. It's the same example, just that the versions of React and React DOM are changed. Now let me click on, and there's also a stop propagation event on parent. If I click on, it is properly printing button clicked. Let's understand this with a use case. So, there's a use case where you have to track the usage of your site. So whenever user clicks anywhere on your website, you want to track the position. Okay. Now in larger project, it is possible that React is just a smaller part of your application, and the other parts of your application are written in other different programming languages. So when you click anywhere on React, you would expect that this event would bubble up and reach the window level to track analytics at the window level. But somewhere if there is a stop propagation event, the event will interfere with the DOM stop propagation event, and it will not allow this event to be recorded at the window level. So this simply means that, what got changed in event delegation React 17? Instead of attaching event handlers to the document that interferes with two different React trees, or it interferes with smaller part of the React project, now React attaches event handlers to the root of the React tree. Initially it used to attach it to the document node. Now these event handlers are attached to the root element. Okay, so even if you have stop propagation event, it is not going to interfere with the window element. You still want to record this event at the window level. It's just that you don't want to propagate it through the tree, but these events would be recorded at the window level. There were many issues that were related to event propagation that being reported because React was attaching event listeners at the document node. Global event listeners on document body were not getting executed because somewhere down the tree somebody had written e.stop propagation, and that was also interfering with other events and stopping it to reach the document level. There was an issue related to React root cuts out React events because of stop propagation. These all issues got solved when React changed the implementation from attaching event listeners to the React root node instead of attaching it to the document level. Let's quickly recap all that we have learned. So event delegation, it basically means that you have event listener at the parent node instead of attaching event listeners to all the child nodes. If you want to understand this with a real world example, consider the example of Twitter. If Twitter has to attach event listeners to all of the tweets, right, there would be many event listeners, and inside one tweet there are also many call actions. So there are going to be many event listeners for just one single tweet, and that's why Twitter implements just one single listener for the parent node, and that parent node listener handles the click functions for all the succeeding nodes. We understood about two fundamental event phases: capturing phase, which is event handlers are being executed from parent to target; bubbling phase, which means event handlers are being executed from target to parent. So first of all, event flows from document to reach target, it executes the event handlers of target, and then it moves from target to parent. Where your event handlers are being executed, that decides the phase in which your event is executed. We saw that React automatically handles event delegation for you. You don't have to attach event listeners. Initially in React 16 and earlier versions, it used to attach event listener at the document node. But there were problems with having nested trees. There were problems when React was just a smaller portion. It was blocking the propagation of event. And now React attaches event handlers at the root node in that React tree. Thank you for listening to this talk patiently. Here are my social media links to stay connected. Thank you and have a great day.
Thank you so much, Ankita. That was really a wonderful talk. I completely enjoyed it. Plus, the all the examples that you gave and the explanations, they were so thorough. I would personally want you to teach me all these concepts in future as well. And this is one of the talks that I would probably bookmark. Thank you so much for this talk. Again, I would like to reiterate that you can all connect with Ankita on the sessions tab on your Hopin portal. You can ask her questions or your doubts or any links that you would want to share, because she shared a couple of sandboxes and a few examples, right? So anything that you would want to know from Ankita, please connect with her backstage on the sessions tab. Now, on the main stage, we have a lightning talk. It's by Dane David. He's a JavaScript developer at Big Binary, and he will be talking about failing gracefully, error boundaries in React. So please extend a warm welcome to Dane. A virtual round of applause for Dane. Welcome on board.
Hi all, good morning. My name is Dane David. I'm a full stack developer at Big Binary. I've been working with JavaScript and React for the past 4 years. And today I'm going to talk about error boundaries in React. So, what are error boundaries? They are React components that catch JavaScript errors that occur anywhere inside their child component tree, log those errors, whether to your server logs and display a fallback UI. Now that is where the React part comes in. You need to have well designed and maybe even include your branding for a better experience for the user to show a fallback UI and even the possibility for the user to go back to the before which he errored. Technically, an error boundary is a React class component that implements either or both of the lifecycle methods get derived state from error and component it catch. It can be used to wrap entire trees. You can wrap the whole application or individual parts of the application. For example, let's take the UI of Facebook. As you can see, the UI is divided into sections. The stories are a separate section. The messenger is a separate section. So if one of the stories were to break, you don't want to bring the whole application down. Instead, we can wrap the story section in its own error boundary, the messenger section in a separate error boundary, and just in case, the whole application in an error boundary. So this is what an error boundary, simple error boundary component looks like. As you can see, both the lifecycle methods get derived state from error and component it catch are defined. The first one returns the state, and inside the render method, you can see that the fallback component is rendered when that state is active. As you can see, the component it catch logs the error to your service, which is Sentry in this case. And you can use it like this. The component tree that you want to wrap inside the error boundary. Now we can see it in action. This is a sign up page of a hypothetical Acme interface, and Alice tries to sign up without knowing that there is a bug with the image upload flow. So she tries to upload the image of her avatar, and boom, there's a white screen. Now this is clearly undesirable because as a user, you would interface and maybe even to not get stuck, especially during something like a sign up flow. Now we can see how React error boundaries solve this problem. Now Bob tries to sign up. Similarly, there is an error, but in this case, we have used React error boundaries. So he tries to upload the image, and even though the error is still present, you can see that the fallback UI has covered it, and he is able to complete his signup successfully. Now, coming back to the lifecycle methods, the get derived state from error is a static method, and it's used for recovering from an error and rendering a fallback UI. It is called during the render phase. That means render phase of the React. That means the rendering is still going. Component cache, on the other hand, it's used for side effects like logging an error to your server or your service or anywhere. So it is called during the commit phase, that is after the fallback UI has been rendered. Technically, you can call set state and render the fallback from inside component. There are certain benefits of using get derived state from error for setting state, which are get derived state from error is server side rendering friendly because there's
Hey,
no
Dane.
commit phase.
Dane,
Sorry.
sorry to interrupt. We can't see your slides. Can you reshare your
Okay.
screen?
There is. Mm, okay, I'll stop sharing and try it again. Share screen. Is the screen visible now? Hello, is the screen visible now?
Hey, yeah, you can switch to your slides. Yes, yes,
Yeah,
good.
it's visible now. Okay. So I was talking about And as you can see, there is no forced synchronous rendering when the commit phase life cycle, when the recovery happens from the commit phase life cycle. Now we can look at the flow of the code in case of an error boundary. Your component renders, an error occurs during rendering, and the get derived state from error of the error boundary is invoked. The state is updated, your fallback UI is rendered, and then after that, component with catch is invoked, which logs the error to your service. Error boundaries catch errors that happen during rendering, inside lifecycle methods, or inside constructors of the whole tree below them. What they do not catch are errors inside event handlers, asynchronous code. It is not yet supported in server-side rendering, and it does not catch, of course, it does not catch the errors thrown inside the error boundary itself. Now, to showcase the flexibility of error boundaries, I've created a sample dashboard application, which contains many widgets. From our earlier discussion, we know that it's better to wrap each widget inside its own error boundary so that if one widget breaks, a fallback is shown instead and the rest of the screen remains intact. But what if there are more errors? What if almost all of the widgets break?
Uh, hey Dane. Uh, Hello Dane.
And the number is incremented from inside the component it catch of the child error boundary. And as soon as the child error count exceeds your threshold, you can throw an error from inside the child error boundary that would trigger the parent error boundary. So once more, bubbling is enabled, and 3 is fine, 4 is fine, and when the fifth widget breaks, your dashboard is brought down. Now, before I end the talk, I would like to talk about I have a helpful library called Reactor Boundary. It's an NPM package, and it handles almost all common cases where we would typically need to write another boundary. It exposes 3 APIs, a component, an HOC, and a hook. The error boundary component is whatever you expect it to be. It has 3 props to specify what to render as a fallback UI. It has a fallback component, a fallback render prop, and in tandem with the Suspense API, it has a fallback prop. And there are also callback props on error and on reset. For example, whatever you typically write inside component with catch, you would want to write inside the on error callback. It also has an HOC version, which pretty much has the same API. It takes a fallback component. It has a on error callback prop as well. It also exports a hook called use error handler. Now, this is useful in some cases. Remember that I mentioned that the error boundaries are not invoked when errors occur inside event handlers. This is because React doesn't require an error boundary to recover from an error that happens inside an event handler. React still knows what to render. But in some cases, in cases where you already have a well-designed fallback UI, it is better to explicitly let the user know that something went wrong as part of this action or as the part of his event. So in such cases, the use error handler hook returns a method called handle error, which can be used inside a try catch block. We can see it in action. Now, clicking both of these buttons will trigger errors. But on the first case, it is not handled using the library. So in that case, you can see that an error actually happened, but the user is confused as to what happened. He's left with no clear feedback. On the other case, with the React error boundary hook that we used, it clearly displays a fallback UI. It can also be used along with data fetching libraries like Apollo, which often return an error object in case something went wrong with the data fetching. So if something went wrong, the error object would be truthy, and you can pass the error object to the hook itself. And in case the error object is truthy, user handler invokes the nearest parent error boundary and renders a fallback. With that, I'd like to conclude my talk, and I'd like to let tell you, all of you, that should try the error boundaries and provide better experiences to your users. You can meet me at the Sessions tab in Hoping. Thank you.
Thank you so much, Dane, for that lightning talk. I know there were some technical difficulties during the talk. The screen went a little blank, at least for me. I don't know if that was the case for the audiences as well. But in case you missed this talk, it was just a lightning talk. So maybe it's a very short duration talk. So maybe you can catch up with him on the Sessions tab. And I'm sure Dane will be happy to help you out in all the questions that you have for him and all the probably the things that you missed out during the talk. So make sure that you connect with him in the Sessions tab. This is the time to take a quick break right now. Have a cup of tea, a cup of coffee, and just get back. We are hoping that there'll be no more technical difficulties and we'll be able to serve you a lot more better. So just grab a cup of tea and get back to us by 11:30 a.m., where Nikhil will present his talk and my co-MC Vishwa will take you to the next set of sessions. Thank you so much.
All right, folks, we are back after our short break. Hope you're enjoying the talks and have had a chance to take a good stroll around the expo and the sessions. We're ready to continue our day with some more amazing talks. Next up, we have Nikhil Sharma with us. Nikhil is software engineer at Postman and will be giving a talk on a road to better UX with suspense and concurrent UI. So, without further ado, let me call upon Nikhil. Nikhil, the stage is yours.
Okay, so I hope my screen is visible and I'm quite audible. So today I'd like to discuss how we can take our UX to the next level with the magic of suspense and concurrent mode. So before starting that, the ones who don't know me, hey, I'm Nikhil. I'm a software engineer at Postman. I mostly handle stuff around design systems, Postman on the web, and Postman's desktop platform. So you can find me on Twitter, you can find me on GitHub. The links are already there in the slides. And I actually love to talk about design systems and performance in React and actually in general. So I'd be glad to connect. Come say hi. Would be a great chat. If you would like to see what all things have I actually done in the past, so there's a small command on the bottom right of the slide which you'd like to actually run inside your terminal, and it actually shows you a nice small card which actually displays all the relevant stuff. So with that being said, let's actually discuss what exactly are we actually going to cover in this particular talk. So moving on the first item, we'll actually discuss how actually do we write code in React today and what it actually proposes as a problem, which is known as a waterfall problem. And we'll also see how suspense actually helps us tackle this part. Secondly, we'll also see how we can actually start prefetching data in background for some other stream while we are on another stream. Thirdly, we'll also see how we can actually reduce that janky spinners loader experience, which we actually show like too many loaders inside a screen or many loaders in succession while we are loading something, with a really cool hook called as use transition. And also finally, we'll also see how we can actually control the behavior of how we actually load data and how we want to show data incrementally, or what should be the sequential actual order, with a really cool API known as suspense list. So with that being said, yeah, let's actually start the journey to this great UX road together. And let's actually start thinking of one specific sentence that comes to our mind. Loading stuff is hard, and I think we are all aware of this fact that this is actually something that we do every day. So if we build a React application, you have to think of so many things, like having some logic to fetch something inside your component did mount. You then have a condition which checks, hey, if my data is loaded or not. If it's loaded, then just show me the data. If it's not, then you just show me a loading indicator or a spinner and whatnot. And I think those conditions where we check our data that if it's loaded or not is something that has actually become an integral part of how we actually code, right? So we actually write these lines hundreds of times a day. So while we're thinking about all those nitty-gritties and that technical mumbo jumbo, we actually also need to stop thinking about what exactly would it impact on our user experience. And this actual demo answers it all. So I think this is something that we have all actually encountered sometime in our life. So there can be something where you actually see that things are bootstrapping, and when things are bootstrapping, there are some other loaders that, hey, I'm fetching some other stuff, and then I'll just show another loader which will say, hey, I'm just loading some other thing, and those succession of loaders actually then give you the final UI. Now, if you see this example, the the responsibility of that loader was something which was to improve your UX. But actually, in this case, where you have too many loaders in a stream or many loaders in succession, it actually is doing like the opposite, right? It actually is creating a suboptimal user experience. With these things in mind, actually, we drill these things down into two simple questions. And that is one, how many spinners that you actually want to show in your app. If you have too many things that are loading asynchronously, do you need to show a loading indicator for each of them, or can you skip some of them? And secondly, do we need to show spinners each and every time if we have something asynchronous? So imagine it actually makes sense if the connection is slower. But what if the user has a faster connection, right? Would it actually be a good idea to show him a loader indicator for that sort of a shorter duration? So to answer these use cases, let's actually try to see how do we actually code today in React. So let's actually imagine a case where we have right now a parent, and let's say this parent is actually doing something asynchronous, which is it has a component did mount where it is actually fetching some data from the server, and while it's fetching something, it has actually not started loading your children. Actually, you have actually started rendering your loading indicator, but you have not started rendering your children. So by this time, you have actually not started loading. There can be a case, right, where one of your child actually wants to do something similar to this parent, like doing something asynchronous when it starts loading, right? And because of this, while your parent has actually not started loading the children, you actually encounter a problem known as waterfalls, right? Where your child will actually start its asynchronous task when the parent completes its asynchronous stuff, which is something which we should have actually parallelized, right? Both of those parent and child could actually have kickstarted their async work together. So this is something that how it works. So the parent is right now fetching, children are not loaded. It then fetches the data, you start renting some children, those can be static, and there is now one child who is actually starting loading, and it has started doing some async stuff right now, and then it starts to get its data back, and you show that final result to the DOM. And this is actually what introduces a problem called as waterfall that I right now discussed. So if you look at this code snippet, this is actually how we right now code, right? We have a use effect or a component did mount. We fetch something. If it's not there, we add a condition that, hey, show a loader. And if the data returns, you just start rendering your main content. So actually in this example, if you see the some other component which is rendered here, it actually has to wait for some time. Like if your parent takes 5 seconds to load something, it has to it would actually start its task after those 5 seconds, which is actually not a good experience, right? It should have started that parallelly. The question that comes to our mind is, can we do it better? Can we improve upon this, since it's actually a problem? So with this, suspense actually comes up to our rescue. So as the name suggests, it's really not a suspense. So it's not going to be the suspense for you after this talk. Now, how suspense helps us is, it actually allows the components to wait for something and also starts rendering things in parallel. So what we do is, we start fetching things way early in our component, and while we are fetching, suspense starts rendering your parents as well as your children nodes simultaneously along with that fetch. So let's see how exactly how it works. Now suspense encounters a parent, and the parent says that, hey, I'm not ready to load, I'm still doing some tasks. Suspense says, it's not an issue, let me just go forward and start rendering your children. And it starts actually rendering something which is static. So if the things are ready, it starts rendering, and the components which were not ready, suspense actually skips those components, or it actually suspended those components, and it's not right now waiting for their data, or it's waiting for them to revert back to it. Now right now suspense has actually not committed its actual result to the DOM. It's because it's right now waiting. Now when this parent and this child are actually ready with the data, suspense is like, hey, okay, you are ready, so let me just render things back to the screen. So now you actually don't have to wait for your parent to finish your task so that your children can start, right? And that's how we actually resolve the waterfall model. If we actually right now see that what's the difference that we actually use to code and how we right now can code is, we have actually started fetching something way early inside our parent component. And you see that now I actually don't need to check for any nullable conditions that if my data is loaded or not, because this is actually suspense handles for you. And I just actually take that resource, and inside my return statement, I'm actually not checking if my resource is there or not. I just simply access it, because I'm actually relying on suspense that, hey, if this component is ready, just render it, or else I have actually given you a prop as a fallback, right, to show a loader. And this is how actually the render as you fetch technique works. And this is the beauty of it. Okay. And this is actually the magic of suspense. So as I earlier said, it allows your components to actually wait for something. So if there's a component that's actually not loaded, we wrap a component inside a suspense block, and we give it something called as a fallback. So now what suspense does is, it sees that, hey, is this component actually ready to load or not? If it's actually ready, it renders it as it is. But if it's not ready, it shows a fallback UI, and it skips this particular component and waits for it to actually finish its task. So enough of the talking. I think let's start seeing those things right now in action. So to show you a demo right now, I have an application which is sort of a Twitter dashboard. And what this dashboard actually shows you is there's a profile section and there's a stuff called about me where it actually shows me some description about me. And I have a section called tweets and it shows me what is right now the current tweet. And when I click on this button, I get a loader, and after some time, I get a next set of tweet that I have actually tweeted. So this is not something that I've actually tweeted, but just for the demo. Okay, so the left side actually shows you how things are going up in synchronous mode, and the right side actually shows you how are things handled via suspense and concurrent mode. So in order to dive in to the code, let's actually see how we did actually write this code as I showed you in the slides earlier. So if you see, I have actually kickstarted my resource fetching way early. And I don't actually check if my data is there or not. I just pretend that like right now it's there and I just access it right away in my render function. So because of this, I actually rely on suspense that if it's ready, you can actually start loading the data. But if it's not ready, start doing something that is right now ready, and you can go ahead and start fetching the other things and other children. Let's see how this description component, which is now written with suspense, actually written inside my app. So I have this file called concurrent app, and inside this I have a suspense block which actually wraps my description component, and I give it a fallback. So if I go to the demo, let's actually switch to concurrent mode. I refresh the app. I go to about me. It shows me a spinner because suspense has actually suspended this UI. It's not ready. And when it is ready, suspense actually comes up to this component and renders it. So far so good, right? It's actually simple. Now let's try to see a case where I have some static content inside my website. So let's assume I have a div here. I have some static content. I close this div and I save this. And now let me go to my demo. We go to about me. And you see, we right now have a loading state, which is actually showing me a loader, even for this static content that is actually rendered. I did not actually want to show a loading state for my whole tab to appear here, right? Because it was only the about me section that was right now loading stuff and not some static content, which was actually static. So what if could be the case where I could just actually load the part which is actually doing something asynchronous and not my whole actual tab? So what we can do to mitigate this, what if I could take my static content out from this suspense block and I take it somewhere out? And this gives a hint to suspense that, hey, this is something that's right now static and I don't need to show a loader here because it is something that's compulsory for me to render. It's not something that's asynchronous. And now if you see, it's right now better user experience, right? Because I have some static content, and even if your about me section is loaded, there was a content that I actually wanted my screen to actually show, and that's actually a better user experience than the other stuff, right? Because you don't actually want to your entire page or your entire section to actually get loaded, and this actually gives a more fine-grained control over what's the actual section inside your app where you want to show your loading state, and not just blatantly give a big shot of spinners or just start loading or spinning the whole of your UI, right? And this is so far so good. It's much better than the other part. Okay, now let's actually deep dive to some other use case, right? Now, what if I have some content which is also asynchronous and I want to show it after my description? So let's actually remove this. Let's actually wrap this inside a suspense block, give it a fallback, and I have a nice spinner here. And inside this, I render a component called as meta description. Now, what it shows you is something which is a sort of an Easter egg, which I actually added inside the app, which is if you go to the about me section, if you go to the about me section, seems to be stuck or seems to be a bit lag. Just a sec. Yeah, I think we are good. So if I right now refresh, and if you check the about me section, I see two spinners. And did you see there is one Easter egg which is in the description? That's Portman, right? And the spelling is right now wrong because I have contrived it intentionally. So you see that this is the line which actually shows you that, hey, the spelling was postman and not Portman, right? So I actually wanted this second message to come after actually this first message appears, right? And this is actually where I want to actually control how my loading or how my data actually appears, right? So if I, what would be a better user experience in this case, right? I would like to actually do is, what I would like is my description to appear first, and the second line, which is actually which something that gives me more info about the description, to appear a bit later, right? And this is actually where I want to gain a more control over my data loading and my loading states. And there's actually where a component called suspense list comes in. So so what if I have these two suspense blocks and I wrap them inside a component called suspense list, and it takes a prop called reveal order. I give it a prop called forwards, close this, and I take this block, I wrap this inside a suspense list. Now what it actually does is, what suspense list thinks is, okay, you have some suspense blocks inside you, and reveal order forwards means whatever we have written first should actually appear first, regardless of the fact that is it loaded first from the server or it is not loaded first from the server. So if you have written suspense for description first, this is actually the one which loads first, regardless of if it is loaded right now or if it's not loaded right now. So you would either see a loading spinner or you rather two loading spinners, but you will never see the case where this second line, which is the meta description, which now comes first. So let's quickly go to the demo. I refresh the page. I go to about me. I see two spinners, and now I see the data. So that's how I actually remove the case where my semantic UI content is actually maintained. The integrity of UI is maintained because I actually wanted to show my description first, and then the line next to it. So now there's never going to be the case where the race condition for the second line to come first appears. Now it's actually the data, it comes along together, or it's the description which comes first. So if you see, it's never going to be that case where you see the second line coming first, right? And that's actually pretty great. So to summarize this part, let's actually see what that are the key takeaways that we get from it. So we actually get a more control over our loading states, because it's actually something that you now don't have to actually handle from your part. It's actually what suspense handles for you by default. So it's actually handled by default. So and you actually handle and you actually have a more control of what exactly or what is the exact area where you actually want to show a loader, and not the whole app or not the whole section. And second point being, since you have render as you fetch with suspense, now you actually don't need to think of the waterfall issues, because your UI and your async tasks are both going on in parallel. And thirdly, of course, you don't need any sorts of those nullable conditions to check your data if it's loaded or not, or don't need to just check for loading spinners, handle any states, because it's all handled by suspense, right? So cool. We have, I think, started to achieve some milestones here, and I think it's right now going to be a better UX following along. But also the question now that arises, it's not something that's super great, right? And it's not something that you can just sell things on. What can we do to like improve this even better, or what can be the improvements of this case? To understand this part even better, let's actually try to see another sorts of a bad UX. So this is something that how React works right now. Imagine you have a product list where you have a search box and you type something, and because of that, React starts updating something inside your page. And that particular update is something which is represented by this big yellow line that you see on the screen, right? And this is the render phase that's right now not interruptible at all. So if your user actually emits something which is an event, for example, he types something inside your search box, React would say that, hey, I have this big sort of a rendering phase which I cannot interrupt. I have to first finish this, and then I can just cater to your user event. And the user would be like, hey, this is not a good UX. My app seems to be stuck when I start typing something inside, right? And obviously your user is not going to be like firing just one event, right? The case is something which is going to be like this. So you can have multiple sorts of user events that can be like right now fired, right? Which React cannot cater, obviously, because it's not right now interruptible. And obviously you would say that, hey, Nikhil, we have an issue and a problem, right? Which we can like solve using debounce, right? and I can just say to the user that, hey, when you stop typing, I will then start updating. But this is also something which the bounds cannot also solve, which is also a suboptimal user experience. Because now your user would also be like, hey, I am typing something, but my app does not respond to it. And this is something like very weird, right? And we can also do something better than this. To address these problems, we then enter concurrent mode. So let's actually see that how that particular diagram changes when we actually enable concurrent mode in React. So now as you see, your big yellow bar is now breakable into like small pieces. So which is something which is an interruptible render phase. So now what React can do is it can now switch between its render phase and it can cater to something that is more important. So in this case, if a user types something which is there can be user event, React actually pauses its render phase, it caters to the user event, and it then resumes its rendering again. So it is something which is similar to a context switching, where you are switching between something that's more on priority. And this is something which reduces that particular stutter or that particular problem inside your product list, which we were talking about, right? So that's great. Concurrency is, I think, great. We can achieve many things with it. But concurrency in general is something which depends upon the scenario where you're using. It can be either CPU bound, which we right now discussed, that there can be a user event which React would want to cater to in priority. Or things can be IO bound, where if you have some data that your component is fetching, React can actually start fetching things and it can actually start to incrementally render your components inside memory while actually not starting to commit results to the DOM, which actually helps to like remove many of the like loading spinners that we right now show, right? So let's actually dive in and see how concurrent mode actually like improves the UX for us, right? So let's quickly go back to the dashboard. Right now I have only concurrent mode enabled, right? So I just go over and I go to synchronous mode as well. So the left side shows you how are we doing the old-fashioned way of React, and the right side shows you how concurrent mode enables it. So let me just quickly refresh. And when I go to About Me section, it should actually show me a spinner, right? Because we will be like, it has not actually started rendering its data and its children. So I go to About Me, it shows me a nice loader, not loaded, and then it actually gives me the data after some time. And then I go to tweets, it's now right now showing me a loader again. And after some time, it also shows me the tweet. Now, by this time, actually, when I was demoing the synchronous mode, what concurrent mode on the right had actually done is it had actually started fetching your resources and it had actually started rendering your stuff behind the scenes in memory. So if I go to this About Me section now, what do you think? Should I get a loading state here or shouldn't I? So let's quickly find this out. So I go to About Me, React has already got this rendered. I click it, and yeah, no spinner, no flash, no loading. It just appears that things were actually there. I go to tweets, hey, it's loaded. No spinners, no loaders. It's something because React has actually like started doing things while you had actually opened the app. And as a developer, I actually know that since I have a profile tab as my first tab, React or a user is actually going to spend some time visiting this particular section, which allows React to give some time or buy some time to actually start rendering stuff. And this is actually great. We have actually removed many spinners that we actually would have shown on the right. Okay, now let's actually try to see one more thing. I go to this next tweet section and let's see what happens when I click on this next tweet button, right? It gives me a nice loader and after some time, it gives me my data back. Now, what's the case when I have a very fast connection, right? I click on this, the spinner comes and just goes. So it's not a very good user experience, right? What if I could just stay on the screen and I just don't show a spinner for some time? And if it exceeds my threshold time, I then start showing the spinner. Now let's try to see how we can actually do this, right? Let's actually try to remove this particular spinner. So let's actually use a hook called as use transition. Let me just comment out this line. And what it shows you, it has a timeout, which is 2000 milliseconds. And it says that, okay, I will actually wait for 2000 milliseconds if your data is loaded or not. So if it's loaded within this 2-second time, I'll actually not show your loader. And if it's not, and this I'll then show the loader. So let's say I have a start transition function, which I need to wrap wherever I am actually setting my state. So it's actually on the button click. Now I just take all of that. I have a start transition takes a function. Inside this, I have my logic, and there's also a really cool value called is pending. So it's a boolean which actually tells you that hey, are things loaded or not. So let's actually disable the button with this is pending thing, and I save this. Well, let's actually see if we are able to remove this particular loader inside our tweets or not. So I get this tweet. Now if I click it, the delay is something that React is waiting for 2 seconds, but my data is actually going to come before that. So I click on the next tweet. I don't show the loader. I stay on that tweet. And now I see the next tweet all in a flash. So no spinner, no loader. Let's do it one more time. I click it, no loader, and I see the tweet instantly. This is such a great user experience, right? We don't show any loading spinners or no janky UX, no sorts of that, too many loaders inside the screen and all that stuff. So catering to those takeaways that we saw. So concurrent mode obviously like allows you to switch between tasks according to priority. And since it is like right now switching between tasks which are more important, it actually does not block the main thread, which it was actually doing earlier. And since concurrent mode is actually being handled by React, you don't have to do anything. Just enable this, and it is high performance by default because it's like already there, and it's something that you would actually want to do. Now you all might be tempting that, hey, this is like something really great. Let me just talk to my managers and TLs and say that, hey, suspense and concurrent mode are really, really great. Let's just try it on a production app. And so this is something that actually Facebook team and the docs have actually answered really well. So suspense and concurrent mode are actually something that are right now very experimental, and the Facebook team is right now looking for more feedbacks upon them on these APIs to make them more stable. So suspense for data fetching is still experimental, while you can still use suspense for lazy loading and stuff. So if you would take my opinion, you can try those in personal projects, but using them something inside your production apps is something that I would not really recommend, right? So this is something which would like involve any sorts of risky bugs that we are might right now be tackling right now. So with this, do we actually finish our road to that better UX? Are we right now great in terms of the best user experience in the world? And the answer is obviously not. So there is obviously a great path ahead to actually tread, right? So if you are like actually trying to see a more practical use case for suspense, go check out Relay. They have React team has actually integrated suspense for data fetching there. So you might want to check that out. There are actually some really cool hooks that concurrent UI actually offers, which is there in the React doc, something like use default value or other concurrent UI patterns. So it's really cool. Go check that out. It's really awesome. So you can find my slides on GitHub with this link, and you can also find my code. The links are right now there. It will be like shared with you guys soon. And on a side note, we are building great things at Postman. So if you'd like to be a part of our journey, come join us at our careers website, and we'll be glad to connect in future. So with this, I'd actually like to end my talk. So a big shout out to all the sponsors and the organizers and all the staff who actually have made this actually a good success and actually have come up with an awesome event like that in amidst the COVID situation. And last but not the least, I would also like to thank you, audience. You guys are great. It was like a great experience sharing my thoughts with you guys. Hope like you have a really great time having or make a better set of and a whole good set of talks going ahead with you over the day and the other day. So that's all from my side. Thank you guys for having me.
That was a super amazing and very insightful talk, Nikhil. I love how well you contrasted the various approaches, explained all the pros and cons and the caveats of each of them, and then actually demoed the changes so that we can visualize the visible improvements in the UX. That was a very, very well put together talk, especially the meme in the end, chef's kiss. So, thank you for that awesome talk. And we are now ready to move forward. Moving on, I'm super excited to introduce our next speaker, Nitish Fanse, Senior Software Engineer at Myntra, who will be talking about thinking of UI as a state machine. Please drop all your clapping hands emojis in the chat to give a very warm welcome to Nitish.
All right. Hello, everyone. So before I get started on this, a big thank you to the entire organizing team here of React Bangalore, Kiran, Kamlesh. Organizing like a remote conference is an extremely hard task, especially because the entire communication mode is an asynchronous sort of a thing, and the entire experience that these guys have brought forward as a speaker has been extremely forthcoming and warm, right? Be it setting up rehearsals, getting people used to the platform. So a big shout out to you guys, to Vishwa and to Varsha as well, and to the sponsors for making this thing possible. So yeah, so thinking of UI as a state machine, as an FSM is what my talk is going to be about. Before I start, something about myself. My name is Nitish. I work at Myntra, and this is my Twitter handle. Typically, if you want to discuss about JS, React interfaces, Golang, Cricket, and recently added to that list chess, then you can connect with me over here. Um, right. So getting started with what is an FSM or a finite state machine, right? So for me, when this problem came forward, not being from a computer science background, it was an extremely hard thing to grapple, especially being because it was a altogether different architecture or a different pattern, and looking up things online weren't pretty much particularly helpful for me. So the things that you normally do, right? You end up reading articles or things, or say blogs or things like that. And if you're from or if you're someone who's worked in a backend ecosystem for a while, you would have known what this is, because a lot of backend architecture designs are based on a finite state machine model. So Wikipedia gives you something like this, which is a finite state machine is a mathematical model of computation, 3 words put together, which make no sense for someone who's seeing it at the first time. To add to some complexity, they have an explanation of what this mathematical model is, where they explain that it is a quintuple, and some Greek alphabets put after that. Before this talk, or before knowing what FSM was, I did not know what the word quintuple meant. So this was something again which I thought was a hard thing to grapple, and which is why I ended up probably making my own definition, which may or may not be right. So people who are experts in computer science theory, please do not shout at me for this. So in my simple understanding, I'll probably call it as an object in memory that stores the state of an entity and handles transition from one state to another based on events. So this entity can be anything in your day-to-day life. You can look at it in your apps that you're working at, and this is basically something. It's an object or a machine which handles deterministic transitions and handles transition from one state to another. So let's take the example of a bulb, right, in your house. You have 2 possible states to represent it. It can either be off or it can be on. There's nothing other than this. So I'm not taking the case of if the bulb explodes or something like that happens. So these are the only 2 possible ways that you can represent a bulb. You turning it on by probably pressing a switch or something is an event that you pass to the bulb or to your switchboard or whatever, and that turns it on. Similarly, you turning it off by pressing a button or a signal, whatever, or a message to it turns it off. So these are 2 events that happen, an off and an on, and the bulb can either be off or on. So it's a very deterministic model of the entity, which is a bulb in this case, right? So this thing entirely, if you look at it in very bare bones term, can constitute a state machine of a bulb. So the entity is the bulb. You have 2 events, and you have 2 states, and you have 2 events. So in this entire talk, right, when I say state, probably it will be the state machine state, and explicitly React state, I'll call it as React state, right? Because the the words can get confusing in the course of the talk. So let's say most of us, I assume, end up working in product-based companies or a B2C company or probably even a B2B company, where the end goal of what you're doing is a transaction. You want the user to do a transaction. If you're working in an e-commerce company, the end goal is that yes, the user places an order and it gets delivered. If it's in a food company delivering food, it is that food gets ordered by the user and it gets delivered. So the entity here, if you look at it, can also go through a state machine sort of architecture. So we take this example of a food delivery app, right? So you have a case of where you place an order on the phone, it goes into a preparing stage, then it goes into, say, food is prepared, it gets dispatched, and finally it gets delivered. So in this case, you see that this is a one-directional state machine, if you have to think of it, where if it is in state 1, after a certain event, it will go to the next state. And this makes the handling of these events very deterministic, because, if I am in a state of preparing, there is no way it can go back to order placed, or if it is in a dispatch state, there is no way it will go back to preparing. So it makes your behavior of your model very deterministic and like an absolute sort of a behavior that you can have. So if I had to give a bare bone definition of it, you can think of an object which goes from one state to another, based when an event occurs. The state machine decides, yes, do I honor the event and do I need to make a transition to a second event? There are certain mutations in this, which is if it is there is an on exit, where as it is about to exit the first state, you can have a callback handler, and the second case is while you are about to enter the next state, there is another callback handler called on enter. Right. So here, this is the slide where I want to just explain that a state. So here, the state that you have in your is purely a React state or your data in your reducer that you're keeping to show your data, to visually represent your data. The state machine is something which is that bit of a state, and you can think of it as a probably a black box which doesn't, where you don't what state transitions are happening, and these are fairly separate things. I just added this one slide because the word state is common across the entire thing. That confusion is not there. So then we come to the part of how to use machine at all. And if you think of it, state machines have been used for probably a long time, and they're just known as mock-ups or prototyping tools. You have multiple prototyping tools like or Miro or things like that, right? And your designer, when he designs these prototypes, says yes, that if this one button is clicked, show this particular part, or it should this part of the form, or I click once, some other button, some other pop-up or a half card should come up. For design, he may not know what that this is a state machine, but if you look at it as a common language between designers and developers, it is actually a state machine that we're talking about. Explicitly, you will not, but I think this is a state machine that we're all talking about, or considering. So if we have another case of us, say, if you have input field where your designer gives you mocks that nothing be just a player. When I start typing a button next to it, turn green. There can be a loading state in between here. That's the button has a loader. If it's on success, there will be a green label at the top. As a failure, it should just highlight. So this thing, if you constitute it, can come up as a state machine for your input component. Right. So what was the usage? Myntra, why did we try to use a state machine? Does it seem like a bit of an overkill, where you can just simply load or something like that, get your application out? So our use case was that we had that trying out certain experimentations with hardware, sort of hardware readers, which would send synchronous events via WebSocket to a browser. The browser was basically the consuming part of the events. And this talk or this use case is exploring this bit of the browser. So the reader would send asynchronous events across a socket, and the browser had to honor these events. And with this, there were other events that the UI had to handle, which are if the internet gets disconnected, the hardware, if there's a power failure in the hardware. For any application to work, you have to have API call, because you're some complexity. You API calls, and with the API calls, you had to show the errors. Do we need a retry and autocorrect mechanism? While an API call is being made, if I get some disconnect events, what do I show in the UI? So this was typically made in our some of the applications that are used in the warehouse. So the idea of designing something like this was that it has to be fairly robust, because people at the warehouse may not understand a message saying something went wrong or retry again, right? For them, the like messages from hardware, especially like for you as a developer, you know that yes, there's an issue with your hardware, just disconnect the wire and reconnect it or restart it, it might work. But for someone working on the floor, efficiency is the key for their processes. A robust mechanism was something that was essential, so that we could probably these errors and these events to the state. So let's say we have one state of S1 and that sends an event E1 with some data. So these are asynchronous events. So when I say events, the events can be anything. They can socket events from a socket. They can be a click handler. They can be a post message, a service worker sync message. So any event that you can define, it can be a custom event that you dispatch. It's all about how you want to honor that particular. There is some event E1 in state S1. And my entity is in, say, state S1. So I have one handler for this, which is add one handler and one event for this. I have three states for the S2 and S3, S1 and event, and all these have to be handled quickly. One way is I possibly have switch case defined, or I have three separate handlers. The complexity of this increases when you have a second event and you have more states. So this goes into a M cross N problem, and here you can have 10 possible handlers for these two events. So you have 5 states, and there are these two events, and for each of these states, I have different ways of handling either of them. So one way of doing this could be in a very verbose way, could be that you have a switch case with the certain states S1, S2, S3, S4, and then another switch on the type of events E1, E2, E3, E4. So again, that is if you look at it in a way, it's a verbose form of writing a particular state machine. So when we thought of certain design parameters, what was it? So one was that it has to be something that is something that is configurable. Something that is reusable and easy to subscribe. So when I say configurable is, can other components also use it, or can the same entity be used across different scenarios? Reusable it wasn't tied to a particular framework. So it was something that we thought that if it was not tied to React, can it be used by itself? And it was something where if components may be it a React app or a Vue app or whatever, can I subscribe to this fairly easily and access the APIs? Right. So this was the broad level sort of architecture of it. On the right, you have a UI which has many components and widgets, suppose, and you have an events channel which is like the input to your state machine. And you have a subscriber bus which your UI is listening to. So say you get a certain event E1, which can be a click event, again, which can be a post message or whatever. And then you go through, it goes through your state machine. The state machine has logic which decides, yes, do I need to honor this event? Do I need to do a transition? And based on the event handlers, you said, yes, if I get E1 and if I'm in state S1, go to a second state S2. This change of transition is published on the subscriber bus, and components which are listening to it can get an update and change their state. So when we made it, typically the left part of it was something that was in Vanilla.js, and the abstraction was added in at a component layer, which tied it to React state. There's a case later where I'll explain where you can have all of this as a custom hook itself if you're only planning to use this in a React application. So if you're to define what a state machine looks like, if you think of it as a class, okay, probably can be a function or whatever, but I like class-based programming. So this was what we had thought of. You have an initialize method, which will probably at the top of it explain what, which initializes as a static method. You have a set of that you can define that these are the two events types that I will honor, a constructor and a handle event, which basically tells the state machine that yes, if I of the state machine, if I have a handle event passed to it and an event is passed to it, how a dispatch event. So this is typically for in case you want to have mutations for other than transition push to subscribers that this is an event that I have dispatched. You have a method called dispatch event, and then the main thing that you use in the state machine is a transition to next state, where from one state you go to the other state. So the idea of the dispatch event here was in case you have exit or an on init flow and you want to publish out events to your subscriber bus, you're in that. But ideally, in a normal design that you want to, you want the transition part of the transition to next state itself, because that internally handles a lot of validations. So these were just simple definitions of what the handle event method does, where just saying event data where you go into the in your transition you that you've attached at the beginning. So you update it and you call the on init of the next stage. As in this, you also return the current state inside your inside this method. So this is purely up to the way you want to implement. Getting them so you have value case the actual transition you're notifying example of a ride sharing app that you have any level of thing. So in general makes to make all possible states. I have a case of if it's successful.
Hey Nitish, Nitish.
Hey folks, so we are having a bit of technical difficulty with Nitish on Nitish's front. Some internet issues that we can't really avoid at this point. But we are hoping that Nitish will be able to join us in the sessions tab. So since you must have missed his talk, if you're still interested in hearing from Nitish and if you have any questions for him, you can move over to the sessions tab and you will be finding Nitish there. We are ready to move on with the next talk. Next up, we have Dipti Roy. So please join me in welcoming our next speaker, Dipti. Dipti is a full stack developer at PayPal who will talk about Machine and its use case with server driven UI. So please give it up in the chat for Dipti.
Yeah, thank you, Vishwa, for the introduction. Hi, everyone. This is Dipti Roy here. So, yeah, Nitish has already set up some context about what are the finite state machines and how we are going to use it in UI. So here I would just like to take this opportunity and extend the concept further and take this concept towards the server-driven UI. So we all have read the automata in our engineering, right? So what are finite state machines? So just a quick real recap of what are finite state machines. So we can take it as an example, right? That we can take an example of the lift, right? A lift can move from the 5th floor to the 6th floor. It can move to the 10th floor, and it can even move to the first floor or the other floors. It also has the ability to stay on the same floor also. Like you can keep clicking on the open button, and you will stay in the same state as you are. Along with the infinite states that you can go in, you all also have the ability to stay in the same state because some of your requirements and some of your validations are still not complete. And you need to complete all those requirements before you move on to the next stage. So that is what finite state machines are in a very short definition. So what is our use case and what are we trying to solve here? So this is a very theoretical description and how it is going to simulate sequential logics. So let us put it in our developer life, like how it is going to help us. So here I would take this opportunity to take an example of PayPal in this particular scenario. What we are trying to achieve in PayPal with finite state machines. So in PayPal, we have so many countries, right? And so many countries have so many regulatory policies. There is KYC for India, and similarly there is CIP for US. There are different many policies that still exist for US for other business accounts and operating accounts. So there are infinite capabilities, and this is not something that PayPal has enforced. This is the government obligations that needs to be completed before you are able to basically move forward and operate your account. Even in India, you must have seen that when you're operating an account and you are actually exceeding certain limit, so you cannot do that before validating that are you, what the user you are, and what your real identity is. You can be a fraud or something else. So we need to validate you because you are doing such large transactions. And
since we all
on such a high level, when we are operating with PayPal, So we need to make sure that we need to extend these solutions to so many countries and so many policies. So how are we going to scale this? We cannot develop one solution, then again build it for some other solution and keep building it, so on and so forth. It might happen that the business requirements keep changing. Our product managers and our designers want to say that, okay, the date of birth should not be there after address, it should come before, and we need to change that sequence in the UI. Or it might happen tomorrow that SSN, let's say, for example, that is very specific to US and it does not exist in India. So are we going to build different capabilities for each country and for so many other policies that are existing? No, right? So our solution to this particular problem is a server-driven UI approach. And what are we going to achieve with that is, so the first one is very simple, that we want to achieve a server-driven UI where all the logics are completely driven by server. So how it is going to help us? We are completely separating our business logic from it. We are reusing our React components. And like we all know, the biggest problem in the front-end world is the bundle size. So as we are moving towards reusing React components, we are moving in the direction, we are not trying to increase the bundle size at all, no matter whatever the scalability comes into picture. And the last one is that it is highly configurable. Like I told you, the example of the business requirements and the product and the design requirements, coupled with the government obligations. So any come what may be, we are highly configurable and we are not going to take our front-end release every now and then. We are trying to keep this process as smooth as possible, and we are just going to drive it everything from our server. So this is what we are going to achieve with that. So what does Machina fit in all these pictures? What is Machina? Machina is a JavaScript framework which is going to help us in achieving this finite state machines. So just a quick basics of how we can use Machina. There are two very simple things that we need to remember always when we are using Machina, is that one is the finite state machines, basically, which will tell you what kind of transitions needs to be there, where you need to stay in, whether you need to move forward or you are not actually validated. There are some data elements missing and you need to stay in the same state. The second is the FDD. What is FDD? It is a unique identifier for the flow. So like we have USCIP, we have India KYC, we can have US FATCA and so many infinite policies and countries. So there has to be some unique identifier which will tell us that, okay, this is my identifier and these are my states for this particular identifier and this is how I need to move in this particular scenario. So the unique identifier for the flow is going to help us achieve in that direction. So how does the unique identifier look like? So I'll just move on to the code piece and try to give some basics of how you can get started with Machina and implement this in your own code base. So here in my FDD, which is, you can just say that it is a unique identifier, I have this identifier which is USCIP. So the main important thing to remember is that we can have a parent FSM and we can have the subsequent child FSMs. What does this mean? It means that in a particular flow, we need to decide that first we need to collect the personal data, we need to then collect the business data. Now in personal data also, there could be so many infinite fields. There could be date of birth, there could be SSN, address, mother's name, and so many different fields, which may or may not exist for other countries and other policies. And so on, we need to drop these things from that particular validation. So on a parent level, we need to decide that how our transitions is going to be like. We can have a consumer, we can have a merchant. So if it is a merchant, we need to collect the business data. If it is not a merchant, we need to skip from personal data to the success page directly. So this is what our parent FSM will tell, that how we need to move from one state to another. We need to define this parent FSM and tell how the structure is going to be. And subsequently, these are our child FSMs: business type, personal data, and success. These are our child states, basically, which will tell that what we need to do in this particular child. So on a very high level, how our parent FSM is going to look like? What are the keywords that we need to remember when we are writing the parent FSM? The first important thing is the initial state, that once we have entered the flow, what it is that we need to start with, what is it our init process that it's going to be. So the initial state is important, and subsequently you have to define all your states, which is going to define this particular one flow of policy. So we can collect the business type, whether it is consumer or merchant. we need to then decide that once this particular child, like I told you that these are the child states that are there. So this is defined as a child and the subflow is the business type. On enter, we need to initiate, and again this particular child is going to have its set of own FSMs, that what this particular child will need to do. And once this particular child has completed all its validation, the data collection and the persistence, and everything is right, he will move to the next thing. This particular child state will be completed, and this parent FSM is telling that, okay, from this state, I now need to move to the personal data state. So this is the parent FSM and how this looks like. At the end level, we reach a success page. Once we are completed with everything, we are saying that we are done, and then it reaches the success page. So this is the flow and this is the states that it looks like. And it's not like that it has to go sequentially. It has to move from this one to this one, and it can skip the states. It can remain in the same states. And that is what the finite state machines is going to help us achieve in that. Very briefly, how our child FSM is going to look like. The parent FSM is only going to contain the state transitions and how the transitions are going to be. But what is the business logic and what all things are there that we need to do on that particular page? What are the data elements that we need to collect? What do we need to persist? And if it's say it's a national ID validation, national ID number. So we need to validate that, okay, for Denmark, we needed to have it as a 13-digit number. The user cannot enter more or less. So those kind of validations, whether they are fulfilled or not, we do that in the child FSM. So this child FSM is completely dependent on the child state that we are into. It has nothing to do with any other states in the parent FSM. So very quickly, how will our business logic in the child FSM will look like? So in the child, again, it will follow the same process like we did in the parent FSM, that we are going to have an initial state, and then subsequently we are going to have n number of child states for this one also. Just the difference that it's going to be there is that in our parent FSM, we are trying to say that what kind of transitions, proper state transitions that is going to happen. But in our child, it is the small business logics, the small UI element logics that we are going to write, and we are going to say that, okay, this step is done. Now we need to move to the next step, and so on and so forth. So the keywords here to remember are that there are the handlers. Similarly, like the parent FSM, we have the initiate thing. And here executors are there, which is different from the parent FSM. So executors are basically having the business logic. Executors will tell that what all the JavaScript logics we need to execute. And the only return functionality of this function, it will perform a lot many things. But there is only two things that this processor can return. The first is whether it was completed, like it was success or not, or it was a failure, like it was incomplete. So if it is completed, that means that we are done and we can move to the exit state. We are successful and this particular child state is completed. But let's say some validations or some logics are failing, even though all the data is filled. This particular thing is still in the incomplete state, and this means that, like there is in a FSM, right? There we can stay on the same state. Like in the lift, we can stay on the same state, and we have to complete the requirements so that we can move to the next state. So this is how the transitions for the child business logic FSM will look like. And once this particular child logic has completed all the states, it will move forward. And once it is a success, it will again give the control back to our parent FSM. The child state is completed, and this will say that now the child substate is completed, and the parent will now decide that what further we need to do with this particular state and how the transitions are going to look like. So this was what is the FDD, which is a unique identifier for our Machina. Moving on to the next slide, this FSM slide is already what is something that I have explained in our code base, that how our parent FSM is going to look like and how our child FSMs is going to work. So this is just that. So now the question comes that how does the one state machine will look like on a very small and very minute level, how you can use Machina, and what is the two things that you can take away from this talk and remember while you are implementing Machina. The first one is that you need to define the initial state. where you are starting and what you want to start with, and then subsequently the child states. You need to remember these two things and you can just get started off with Machina. So on a very high level, how the holistic view of this particular flow will look like. The first one is that we need to give the key identifier for the flow. Then comes the child, the parent and the child FSMs. We have to define the initial state and the transition states. And these three are the subsequent FSM logics. Like we have handlers. Handlers are there for the parent FSM, which will tell the next state transition. And executors are there for the child FSM, which is going to give you the business logic and whether that completion has been achieved or not. And once these things are achieved, what is the next state that we need to define and where we need to move in. So this is the holistic picture of Machina and the state machines that looks like. So what is the advantage? We already discussed some kind of advantages in our initial slides. But apart from all the advantages of scaling the solution to different countries and policies and all those things, driving it from the server, there is one further advantage that comes from our experience from the product managers, from the design, that they will say that we need to remove the UI elements. We don't want to have it like this. We need to have it like this and that, and we can reconfigure everything. But we do not need to touch our front end, our React components at all. And we can remove, we can add, we can tangle, we can do anything that we want to in this particular screen, and it will be server driven. So that is the advantage that we are having with the state machines. So yeah, that was all from my side. Thank you guys for having me in React Bangalore. Thank you.
Thank you so much, Dipti. That was another really amazing and a very thorough talk of the day by Dipti. I remember taking a course on theory of computation in college. If only that course would have been so much fun if someone would have been able to, explain these concepts to me in class just as thoroughly and in a very fun manner. So that was a very interesting talk. Thank you so much, Dipti. If you have any questions for her, please make sure that you drop by her room in sessions when you can. Moving on, let's give a round of virtual applause to our next speaker, Thiyagraj, front-end engineer at dgraph Labs, who will be talking about untangling reducers into reusable patterns.
Okay. Hey, everyone. I hope you're having a great time at React Day. I know there have been a few technical hiccups, but that's okay. I mean, it's an online conference, bound to happen, right? So today I'll be talking about untangling reducers into reusable patterns. So the first question is, why do we even need to talk about reducers on a React Day, right? So reducers are very handy for developers. In the React ecosystem, we encounter reducer-based state management quite often. It could be as primitive as use reducer that is baked within the framework, or a complete state management solution like Redux. So this talk is applicable to any complex state logic that involves multiple subvalues, especially when the next state depends on the previous one. So in the next 10 minutes, I'll be quickly sharing a bunch of ideas how you can untangle reducers into patterns that can be used across your application so that you can build your app faster. Without wasting any of the time, let's understand what is the problem we are trying to solve here. So this might look very familiar. Don't bother about reading the code. The obvious guess is that it's a long switch case, and reducers tend to grow quickly in an application. So the length increases. The more actions you put in, the more cases you need to handle. So the reducer kind of gets stretched out, right? But here, length is not just the concern here. To understand better, let's zoom in and dissect this a bit further to get more perspective. So just to be on the same plane, what is state? State is just a bunch of values that are associated together, which responds to some event. In this case, in the reducer world, it's actions. In this example, if you see, there is an enabled field. That's a flag that can hold a Boolean value. And different actions can have different effect on this piece of state. So now the problem here I see is that I need to read the entire reducer just to know what all actions in the application have an impact to enable field. If I need to introduce another flag element, I have to go through each action to which it needs to respond to. So there's no central definition, and this reducer tends to become a huge giant black box, and we do not really know how it behaves. We just know that, hey, it just takes a bunch of inputs and spits out an output, right? Also, there could be transformations and derivations based on the action to reduce the new state. For example, you're initializing the state and you might set a property based on a value. Like here, enable is set true if the payload has property enable with a string value yes, right? So there's some sort of a deduction of the state based on the payload. So in a nutshell, what are the problems? There's a lot of repetitive code, right? Which quickly grows and becomes extensive and adds more risk or add more risk of error while editing. It makes it hard to extend it. Most importantly, it is difficult to identify how substate reacts to different actions. So let's take one step back and understand why did we decide this is the right way to write a reducer? To understand better, let's visit the mental model we have for a reducer right now. So in my head, I imagine reducer like a funnel. It takes two key ingredients. First is the current state. Second is the action. An action is basically an event, right? In the reducer world again. So the reducer spits out a new state. That's what we are taught in our 101s, and that's absolutely correct, right? A reducer is just a pure function that derives new state based on the current state and the action. And of course, the natural fit to solve this problem is a switch case, right? So inside the switch case, we take the action, identify its type, calculate the new state. Sometimes you need to know what the current state is. Sometimes you might not. Right? For example, toggling a Boolean flag may require the current state, but also sometimes it can be simply extracting a value from the action object and assign it to some part of the state. So the switch control pattern solves this perfectly. And this is why we are stuck with a big black box function, right? Nobody from outside is controlling the black box or defining its behavior at least, right? There's no behavior defined at the top level. So instead of, let's put it in this way, instead of building a funnel by yourself, let's create a constraint-based funnel. So let's assume we can create a factory that accepts a spec that defines certain behavior or patterns. And basically your factory will return a funnel instead of writing one long switch case by yourself. So something we need to note here is that the funnel is still a black box. We don't know the implementation details, but we have a definition that describes how this black box behaves. That's the difference, right? And this is called a factory design pattern, or you can even call it a higher order reducer. So let's take the same example of enable field and create a spec for it. So let's not worry about how the factory creates the funnel for you. Let's focus on how do we describe the funnel. Right? So here's a simple config for a reducer factory you can start with for the same example which we saw earlier, right? So here, I don't want to get into implementation details here, but let's kind of read it out. So what does it communicate to us? So it says, hey, give me a field called enable, right? That's a substate value here. And basically it follows a pattern. And what is a pattern? It's a switch. So it's a switch means it can go on, it can go off, right? So we say that, okay, the switch goes on if you see an action with type enabled, and the switch goes off if you encounter an action with type disabled or clear form, right? So you can extend this configuration as well, right? And extending it becomes very simple. If you want to grab some data from payload and update the state, we can just add a new property that accepts the action it accepts an action, the field from the payload you need to look into. Also, you can define, you can also define with what any function you need to apply on that particular data before you persist it in the state, right? It can be any transformer. Like in this example, you're providing a transformer function which looks into the value and sees if it's a yes string value, right? The same way we did in the previous case. So how does this help, right? So some obvious deductions here. One is that it's very declarative. So you end up with less code to manage. It's highly extensible. You can always, add more patterns. You can extend the configuration to support more different types of behavior. It allows composition, so you are not ending up with a linear code where you need to like copy paste, and editing becomes pretty difficult. So when you're dealing with objects, composition becomes very clear. And the best part is like the state behavior is quite predictable, right? You can easily identify the substate's exposure to actions and say, hey, this state element basically responds to these set of actions, right? That is possible now. It's no more just a black box, but you have a black box with some meta information around it, right? Which you define, and that's how the funnel is controlled. So these patterns can be extended not just for switch, but it can go for toggle. Also, it can go for list, like you can append, edit, or update elements inside a list. So you can create your own custom patterns, whatever suits your use case. So naturally, the first question would be like, how do I get started? Hey, is there any tool for it? No, I would not like get into like suggest use this or use that, but you can always build one of these. Like it's not like rocket science. You don't need to. It's also like framework agnostic, so you don't really need to. You can reuse it across different frameworks, irrespective, because Reducer follows the same pattern. If you really want to, not get into the business of reinventing, you can look at Reducer Factory by Kubrick. We wrote that a while back, and which kind of solved most of our use cases in our applications. You can even, take some inspiration from the configuration. How can you define usable configurations? Also, if you want to get more perspective around this area, you can visit recipes in Redux official site under structuring Reducer. Redux comes up with a lot of rituals. There are ways to mitigate all those rituals and not deal with all that boilerplate. So you can have a look over there to get more inspiration as well. Okay, there. Before we kind of summarize, there's an Easter egg. So this factory, which we were talking about, doesn't necessarily need to just spit out a Reducer. So you can think of, hey, I define a configuration. Maybe let me say that, hey, I have this data. There's a mechanism to get this data from the server. I define where this resource is, and you can also do a lot of fun things, right? You can not just generate the Reducer, but you can also give types, actions, even functions, operations, which fetch data and sets the state. Like let's say you are loading data, a list data from the server, right? So you can do a lot of fun things over there. So quick recap. So first, we try to visit the mental model, which we have around user Reducer. We try to identify the problems. The big problem was that you cannot identify the exposure of state. It's very imperative. Obviously, the code will grow. And the solution which we proposed is, hey, why not go with a Reducer-based, a Reducer factory that will allow to have a state-first Reducer, and also you can test these patterns in isolation, right? You don't need to test all the time at a Reducer level, but at a pattern level, and it's very declarative, right? And also we saw that these can be extended. These patterns can be extended to operations and side effects, right? So yeah, that's the end. You can ask me any follow-up questions in these sessions, or you can even post it on Twitter. I'm quite active over there. So yeah, that's the end of the talk. Over to you, guys.
Thank you so much, Thiyagraj. That was an amazing talk. Yeah, so that was an amazing talk. It just always blows my mind how lightning talks, even though they're just 10-15 minute talks, speakers, our awesome speakers, are able to pack so much information into these short and brief talks. That was definitely a very information packed talk. So I'm going to take some time, a quick break that helps me mull over all these concepts that I just learned about. And you can also take this time to go grab lunch or maybe connect with some speakers, any attendees in the conference. So it's time for a lunch break that we're going to have, and we will see you right back here at 1:50 p.m. IST. Our next set of speakers are going to join us after the break. Anshuman Barma, Siddharth Chetrapal, and Vivek Kumar Bansal to talk about some really interesting topics about React. So make sure that you join us again right back after the break at 1:50 p.m.
Hi, everyone. Welcome back after that break. We all hope that you've had your lunch and you're ready for the next set of sessions that we are going to take you through. Just a call out that we have some exciting goodies. We have some great giveaways. So please tweet your learnings with hashtag TIL React Day In and tag React Day In as well. And we will select the best tweets and then share the goodies with you. You can also post your fun screenshots with speakers, MCs, co-participants with the hashtag FunReactDayIn and tag ReactDayIn as well. And get hold of the cool goodies that we are, just about giving away. Also, a huge shout out to all our sponsors who've made this conference possible. Without them, this would not have been possible. And as we mentioned at the beginning of the conference, you can visit them and you can see the list of our sponsors in the Expo tab that you're seeing on the screen right now. So make sure that you go and check it out during your breaks. Archimedes, Atlantis, Auth0, ClearTax, Geeky Ants, GoIBibo.com, Grow, Harness, Hasura, Disney Hotstar, Open House, Column, Razorpay, Swiggy, and Exactly. Thank you so much for sponsoring us. So now let's begin with the next set of our speakers and the next set of our talks. We'll start with a lightning talk because we usually end with a lightning talk. So we thought let's just start with the break with a quick lightning talk. This lightning talk is by Anshuman Verma. He's a front-end engineer at Clarisites, and he will be talking about virtualization in React. So please give a virtual round of applause for Anshuman.
Hey everyone, so thanks for joining. So today I'll be talking about virtualization in React and what it means, how you can apply that in your applications to gain some performance benefits. So let's dive in. So before we start, a little bit about me. I work as a software engineer at Clarisites. I am interested in open source and web performance or web ecosystem in general, and I enjoy playing football and watching anime. Here are my GitHub and Twitter handles. So let's dive in. So if you look at the web applications these days, they are mostly list. And by list, I mean, it could be a list of anything. It could be a list of posts for a social media application. It could be a list of messages for a chat application, or it could be a list of products or food for any e-commerce application. So lists are essentially everywhere in the web application. So, and by list, I mean, I hope I'm clear that list could be it could be a list of images, it could be a list of divs or anything, and not just HTML lists. Right. So, so what is the problem exactly? So what we're used to, we get some data, we map over the data, and then we return some JSX, right, or code. So the problem comes in, like, let's say you create a component, you create a list component, you ship it to production, and you encounter that, okay, the list contains a large number of elements, let's say 5,000 or something. So the end user will see a noticeable jank because you have to pay a lot of cost to render all the 5,000 items at your render time, right? So you have to pay a lot of upfront cost to render your list, right? So how can we improve that? So there's a concept called virtualization or windowing, so which essentially means that you only render what's in the viewport, right? So you don't pay unnecessary cost of rendering all the list items, which may not even be visible to the user at the start. So to give you a visual idea of how this looks, on the left we have a regular list where you render all the list items up front, and on the right we have a virtualized list where you only render the items which are visible in the viewport depending on the scroll position, right? So this concept is not just specific to web. So in Android also we have a widget called Recycler View, which only loads the amount of data in memory which is essentially visible to the user. And in fact, this concept is also applicable in games where the graphics renderer only renders the amount of data which is visible in front of the camera or around the character that is presently there, right? So this concept is pretty powerful as it helps us cut down a lot of render cost, and you don't have to pay that amount of cost up front, right? So, and how it works is you continuously so looking at the diagram, if you look at the virtualized scrolling thing, as the user scrolls through the list, you continuously remove the DOM elements which are getting off the viewport and continuously render elements which are being inserted in the viewport, right? So if you look at the demo, so I have prepared a simple list here. If I were to inspect the element, so you can see that okay, so we have a list here and we have some list items here, right? So if I were to scroll through this list, you can see that new divs are being continuously inserted and the old ones are being continuously removed. So this, so at any instant of time, you only render what's visible in the viewport, which also keeps the memory footprint of the application low. And so yeah, all the good gains with in your application, right? So all good. So but yeah, obviously it's not a silver bullet that using which you can like make your application like super performant in one go. There are obviously some trade-offs that you have to make, and you have to essentially do a cost-benefit analysis of whether it makes sense to apply virtualization or not. So obviously there are accessibility concerns, because at any instant of time you can't be sure that some element is in the DOM or not. Your list won't be searchable, fully searchable, because all the list items are not rendered, and if your list item is heavy, if your list item has a lot of computation, it can potentially show jank, right? So let me just edit this compute function. So in this virtualized list, I have added a compute function, which essentially just is gonna do a large number of computation to render every list item. So if I were to scroll it now, you can see that there's still a noticeable lag, and that is because of the rendering engine is not able to keep up with the scroll, and that's why we see a noticeable amount of lag. So the trade-off is that heavy list items can potentially show jank, so you need to make sure that you are keeping them as light as possible. Presently in the React ecosystem, there are two popular libraries by the same author. One is React Window, which is like a pretty minimal library. One is React Virtualize, which has a lot of functionality out of the box. So in the demo, I have used React Window. So we are not gonna go into the code now. So what it essentially does is you essentially have a wrapper over your list, and you have a large wrapper which essentially decides on the scroll position, like which cells are to be rendered and which are to be hidden. So yeah, so some suggestions from me if you were to virtualize your list. So I'd suggest that you pre-compute all the data, or in chunks if possible. So if you do any sort of computation in your cell, it's going to get heavy at render time or at runtime. So your application will feel janky, which obviously kills the point of virtualizing your list or component. And you need to keep the cell DOM as light as possible, because React has to do a lot of work to essentially mirror your VDOM to the actual DOM that we have, right? So if, let's say, you have a large nested DOM tree that needs to be for each list. If you have a large nested DOM tree, then React has to do a lot of work to essentially insert it into the DOM. And while the user scrolls, React also has to do work to remove that from the DOM and then continuously add new elements. So that can potentially slow the scroll and could result in a bad user experience. And the most important suggestion is do not prematurely apply virtualization just because it sounds cool. You need to do an analysis and decide whether it makes sense to apply virtualization or not. So let's say, and that totally depends on the application that you have. So it might not even make sense to apply virtualization to a list of 5,000 elements, or it can even be applied to a list of 100 elements, right? So so that is the analysis that you need to do. So for instance, if you have, let's say, a large number of elements and all of them are rendered at once, so if that at render time slows down your application, you should obviously do it. And if you have, if every element in your list is like super heavy, right, it does a lot of computation, it's some heavy widget or chart or something, so you can have it, right? So here are a few resources. So there are also talks to support this out of the box. So as in we want some native support. So it's still in talks. We have not finalized yet. There's a spec that you can read through, and there's also a great article on web.dev on how you can virtualize long lists using React Window. So I hope it's a great article. I'd suggest you check it out. And so yeah, that's all I have. Thanks for having me, and thanks for the organizers for putting together this event. And I also have a session, so if you have any doubts or concerns, you can join me on the session, and then we can have a chat there.
Thank you so much, Anshuman. That was such a quick and sweet and brief explanation of how virtualization works. And I also enjoyed the part where you explained that we should not prematurely optimize before we can start off something. That was in a very short amount of time. You kind of covered all the topics and everything that you wanted to say. So thank you for that amazing lightning talk. And our next talk, before I can announce the next talk, I would like to say that if you want to catch up with Anshuman, and if you want to know more about how virtualization works and maybe the inner details, because it was the lightning talk and he couldn't have more than 10 minutes, then you can catch him in the sessions tab, which is displayed right on your screen. So just go over there, catch up with him, and catch up with all the other speakers if you want to. They're available right there in a parallel thread to this main stage. Calling on main stage now, we have Siddharth Kshetrapal. He is a UI developer at Code Sandbox, and he will be talking about building smooth interactive interfaces with React. So please give a huge virtual round of applause for Siddharth.
Hey, hi, Vacha.
Hi, Siddharth.
Okay, I'm gonna share my screen. There you go. All right. So, hi everyone, I'm Sid, and I work on a bunch of side projects. It's hard to sum it up, so I'm just going to jump straight into the talk. So I'm a developer at Code Sandbox, and I spent the last year working on a bunch of interactions. So I'm a front end developer, which means I don't really spend a lot of time on the editor or the compiler behind Code Sandbox. I spend most of the time on the UI and how people touch things and all that. So I spent a lot of time working on interactivity last year. So when you interact with the interface, what should move, how do we use animations, and a bunch of things. So, and I want to ask this question in general to begin with, which is, what makes an interface good to interact with, right? So there's basic things like, I'm saying basic, it's not basic. There's some things which are common knowledge, which are like, the design should be clean, right? And it should be fast. But then there are also a bunch of things which are not so common on the web, but are really powerful, like motion. So animations are usually, chucked into this category where if you're building a website, which is like for a game or for a movie, then you'll use massive animations and there'll be a lot of interaction and stuff. But if it's a professional website, we tend to ignore animations. And I'm here to pitch that when used tastefully, subtle animations can actually give a lot of context to your user and drive the interface essentially. So I'll stop talking now and I'll start showing you what I mean. So for this talk, I built like a very tiny social, what do you call it? Like a social media website. It's called Saturday, and the logic is that it's only open on Saturdays. I know, amazing. So so when you go to Saturday, it looks like your boring traditional social media, and you can click a post and you can read it. There are comments. So for example, Pavitra's post, I'm not calling it a tweet, Pavitra's post has a few comments here. And you'll notice that when I click something, it just snaps open, right? So there's no context given of what's happening. So for example, if I click Neha's post, it just snaps open over here. And same goes for reply. So it's loading some reply and then just pop open there, which is kind of like a janky experience. It's especially visible when you load new posts. So if I, like on the top, you have more posts. When you click it, those posts just show up. And a lot of times you lose context of where you were earlier. But now you have these posts all of a sudden like thrown into your face like this. So, and that's not like, it's not uncommon, right? This is something that happens on a lot of websites. A lot of our favorite websites is like, you forget where you were, you lose context because content just snaps at you. So, and this is something that mobile applications have kind of had like a lot of years ahead of web applications, where they use motion to really set the context of where you are and where you're going. And I think that there's no excuse for web applications not to have the same level, because to be honest, like the tech is there now. The technology and the browsers and internet support, like we're at a stage where we can't really use that as an excuse. Now it's just, we just need to do a lot of implementation work. So, okay, so let me start by showing you something. So for example, I'm gonna reload this page if I can. Perfect. So this tweet, I'm gonna keep saying tweet, this post that I clicked, it snaps open, right? So the bare minimum that we can do, and this is something that a lot of websites do, is fade it in. So every example that I'm giving in this talk, I've built it with Framer Motion just because that's what I've been using. But you can do everything with CSS animations as well. So this is not necessarily a JavaScript or a React thing. But if you are using React, then Framer Motion is really cool to do it. But you can do it with CSS. So what I'm going to do is a bit of live coding around how Framer Motion works is you can take any element and you can say motion.div, right? So like style component has a style.div, they have motion.div. And because I'm using a different component library, I'm going to use the as prop of that and just say I'm going to use motion.div. Now, by itself, this doesn't really do anything, but it gives you access to these two props. So there's an initial prop and there's an animate prop. With the initial, you can say, what is the entry state? So in my case, I'm going to say it's invisible. It has 0 opacity. And then I want to animate it to opacity of 1, right? So just by doing this, what I get is when I click this, you can see it's fading in, right? And then when you click out, you go back to the thing. So it gives you a little interaction of something has changed, right? Especially if you click the first one, where it's in the same location, you still get a feeling that something has changed. Let's do the same with these replies. I'm going to open, there's a bunch of code, so I'll try to like really narrow down the focus of where you should be looking. And all right, so this one I've already put motion, and it has all the elements. So this is a list. So this is motion.ul, has an initial opacity of 0, animation opacity, it goes to 1. And then for the transition, I basically have 0 seconds. I'm going to change this to 0.2 seconds, like 200 milliseconds. And now you should be able to see the difference. So when I load this, you see this fades in. So already we're saying like there's some more context, that more content has just arrived. Otherwise, if it just snaps into place, you often miss what was there. But when it fades in, now you know this is new content that was loaded. Same goes for like if I write something here, like I don't know what to write, wow, right? That also just pops in, which is fine in this case, but it's even nicer if it fades in. So I'm going to change branches because I also feel like this is kind of silly that there's nothing here. So it would be nice if we add a spinner. And the spinner gives some context, but again, unless it fades in, you kind of miss the thing. Okay, so changing branches because I have a bunch of code written already. Force checkout, discard files, great. Okay, so the next thing I want to like show you and focus on is that even when we're fading in, we can use animation for a subtle change, which is I'm going to say y, which translates to like what is the y position. So if I say y 40, it converts to a CSS of translate y minus 40, so it goes up. And I'm going to say the y should go from minus 40 to 0. And what this will do is it will kind of give you the feel of like it's popping out of the post, right? So when you click here, first the post fades in and then your content pops out. So that establishes that these replies are part of the post, right? So the post came in and then the attached data came from the post. And this is something which is very common in games, in mobile applications. Just that in web, we don't really do it. Okay, let's see. I like that better. I'm also going to attach the same thing to this last form. Okay, that's good. So, and now when I do a reply, I'm going to say, Pavitra, you're so smart. This is not sarcasm. She's actually very smart. You'll see that it pops in, but there's some sort of delay, right? So if I type another one, there's a delay happening here. And what I've tried to simulate here is a lot of times what we do is you type something, you send an API request, it succeeds, and then we show it, right? So there's this gap over there, which feels odd in interfaces when you're interacting. And what I want to push for is like optimistic updates. So when you add a comment over here, it should optimistically add it as if the API request would succeed. And then if it fails, then we handle the error, right? So it's a bit tricky because it's always easier to wait for validation. But in a lot of cases, the user doesn't really care what your server validation is, of course. So it's always like nicer for the user, if you can, to show it first and then do the harder error handling of like, if it didn't succeed, then you have to bring it back into the editor and show a red thing. So what I'm going to do to simulate it is just remove the delay I have because I don't have a real backend to to show you these examples. So I'm just going to remove the delay, and now you'll see that when I write something, new comment, it pops in right away, right? And then it's sending requests to the hypothetical API and making sure it's persistent, which is again something that mobile applications and games have always done, right? They have a sync, they have a persist, which is after the user comes first, and then all of the technical mumbo jumbo that we do comes. Okay, so let's take this to another step. Am I moving too fast? I don't know. I've finished my talk in 15 minutes. So I'm going to go through my notes. I'm sorry. I've talked about optimistic updates. Okay, so this one's really cool. Let's go back here. When we're loading new posts, you'll notice that even though they fade in, you still lose context of where you were earlier. And there's a very nice way of making sure that the context is still there, which is to use layout animation. So with frame and motion, it's very easy to do layout animations, which is, this is my, let's see, these are my mapping through the posts, and this is the list element. And inside that, I have the post. So the list element is already a motion.li instead of, say, just an li. And what I'm going to do is I'm going to remove this fade and instead add a layout prop. Now, what this layout prop does is it looks at all the siblings that have a layout and then tries to animate smartly. So if you insert something in between, it will try to make some space. Let me show you how that actually looks. I'm going to save. So now when I click on this header, you'll see that this new div was inserted, which automatically pushed the rest of the content. Let me show you again, because it's easy to miss. When I click, all of the content gets pushed on because there's a new element. And now, of course, when I load more posts, something similar should happen. And you see like a bunch of posts came. So Nitish's post, which was the first one, went down really fast. And I really like this kind of layout animation because it gives you a context of this is where we were with Nitish and Pavitra on like their posts over here. And when I click load more, it got pushed down. So you know that if you scroll down, their posts are still there. And it's really nice, especially if you can see it at the bottom because you see it moving. But even if it goes out, it will just go out faster. But you still have a context of this is where I was. When I click new post, new things came, and now the previous position is down there. So I'm comparing it to Twitter, where sometimes you miss where you were. And I'm sure they have the reasons for it. All right, so okay, I'm going to check out to the pre-final branch. Cool. So for this one, I want to show something. And this is, I've actually deployed this one. So if you want to follow along, you can. If you open saturday.versal.app, especially on your mobile phones, because it looks really good on mobile, more than web. So if you go to saturday.versal.app, you can play around with this app as well while I'm talking about it, just to get a sense of the interactions. These are always nicer to touch and feel than just see on a video. So all right, so now let me show you another example here of what I'm trying to talk about. So I'm going to open this Twitter back button. So this is the, wait, let me also show you, whoops, I need my URL bar. Okay, so when you go to Twitter, there's something interesting that happens. When I click on a tweet, it opens in a different, and then there's a back button, right? When I click back, it on the storyline goes back, but the arrow doesn't really have anything, right? It's not like it's going to the left. So the arrow is pointing somewhere, but the arrow, like for all we know, could have been pointed up, down, it could have been across, it doesn't really matter, right? And this is something that we see a lot, where a lot of the icons have become like, they're not actually symbols anymore. They're just icons that we identify, like a hamburger or a back button. We just know we're going back in history, but the arrow itself could have been anything, right? And let me show you what you would see on a mobile application. So this is the same application, same company, but on mobile. So when I click on one of these tweets, when I click on the first one, it flows from the right. Let me play it down. So when you click it, the new tweet came from the right. So there's a sense of like you're going into a different screen. And now when you click left, which is back and pointing towards left, you're actually going to the left screen, right? So there's a notion of like there's two screens, one is on the right, one is on the left. And you get some directional feeling when you click left, right? So you're going right into the details, and then you go left to zoom out. Let me show you another one. This one is really nice. So this one's Instagram. And when I click on the camera button on top, the camera thing slides from the left. So it's very interesting. They could have just popped the camera, but they've chosen to do it. It slides the UI from the left. And what's really cool is that it's also a hint that you can actually drag it back. So to open something, all right.
Hey, Sid. Hi. Are you facing any difficulties?
Yeah, I think my mic got disconnected on its own. What's the last thing you heard?
Okay. I think we had till now just 2 seconds or 5 seconds back. I think we stopped.
Perfect. Okay. So
when something came up, right?
Yeah. Oh yeah. Perfect then. All right. Sorry about that. Okay, I'm gonna go back here then. So let me. Yeah, I'm just gonna quickly repeat this one because I'm not sure where I got stuck. So what Instagram does is camera comes from the left, and what's really good about that is they've established that if you drag from the left, it's always there, and then if you close, you can drag it back to the right. And this is how you can use motions and animations to establish user patterns. It's not all good. I found this really cool platform versus animation fight, which must have happened inside Instagram. So look at this name on the top, and there's like this tiny menu, right? Or at least understand like down arrow means menu now because we see it a lot. And when you click this, I expected something to come here or a drop down or something to come from the top maybe. But what happens is when you click it, it comes from the bottom, which makes no sense when you think about like where is the arrow pointing? Like why is it coming from? But the iOS, what do you say? iOS UI guidelines say that the menu should come from the bottom, and that they also copy the same to Android. But the icon is just like it feels like something is off, right? So for Saturday, what I was trying to do is I tried to do a different pattern, which is when you click on a post, because it's full screen, it kind of zooms in, right? So you're going into the details of a post and you zoom into it. And then when you click it, you zoom out of it. So when I click it, it zooms in. And this is like a whole page. So I'm trying to scroll, but I can't because it's everything. And when I close, it goes back into the same position. So let me show you how this works. I really like this part. And there are like multiple ways to do it. But the way I like to do it is slightly imperative. So I have this post element, right? So what I'm doing is when you click this, there are two elements of the same thing. So there's the post, and then there's another post absolutely positioned on top of it. And I calculate the initial Y position by just taking like what is the post element and like get the box and see where the box started. That is my initial position. So with frame and motion, I say initial position is Y is the initial Y, which is calculated imperatively, and animated to Y0. And then I also have an exit animation, which is go back to the initial position. And this is really cool because this could be anywhere. Like I could put this at the edge of the screen and then open it, and it comes from the top. When I close it, it tucks it back, and then I see the house post again, which by the way is like really cool. You should follow her. She's putting like really interesting art stuff. And so again, pops it down, closes back to the same position. And so now we're establishing, like, when you look at this, this is not a new pattern that, something blows up and something goes back. But what's really interesting is that when it zooms in, this is not a new pattern, or this is not an isolated pattern even on the web. We have dialogues and modals which are the same pattern, which also gives us a good template for what should be the accessibility story here. So for example, while I'm here, I should be able to just press escape and exit, right? So I open this, let me put my keyboard thingy. right? And when I press escape, it should close. Similarly, I am here. When I start tabbing, I should be able to tab between the close button and the comment button. And I should be in a focus trap, right? So when you open a dialog and you keep tabbing, it should loop between these two or loop between the controls of a dialog instead of going out of the dialog and going somewhere like go to the footer and stuff. So we already have these semantics already established, just that we can use them more creatively over here. So this essentially is a dialog which opens from source, closes, goes back into the source. Now, there's another thing, and this is where I got carried away, but I think it's a good idea, especially on mobile, which is if when you open this, it goes up, shouldn't you also be able to push it down to set it back into its place? And luckily for us, Framer Motion, and there's a bunch of good drag libraries in React. Framer Motion has a drag prop. Sorry, I'm going to disable keyboard now. We don't need it. And what this lets us do is lets us like drag it. And by default, it's like it's Spring animations. So you can drag and send it wherever. I'm going to put these constraints that when you try to drag it, it should stay at a certain spot. So let's open this. Now, you see when I drag it and I leave it, it springs back into position. And we're getting all of this for free because of Framer Motion uses Spring animations. So when I drag it back, it snaps in a very Spring way, right? So you pull a spring and you leave it, goes really fast and then slows down, like how a spring should work. So I can drag it, it goes back. And now what I've done is when you stop dragging, you can see how much was it dragged. So I'm using the offset, and what I'm trying to say here is if it was dragged more than 100 pixels in this direction or 100 pixels in that direction, snap it back. I'm saying deselect the post, put it back into its place. So let me show you. When I start dragging and I drag too much, it goes there. Let's put this even, actually, let's try to open this one. And I see when I drag it, I drag enough, it goes back into this position. And the most interesting part is because I'm using this initial Y, it always knows which position to snap back to. So no matter where I drag it, it nicely falls back into the same position and then disappears. And then the original one is already behind it, right? Remember, this is an absolute position clone of the original. So when I drag it, it goes back. And finally, what you also, if you're building something like this, what would be really interesting is to give the user some hints of what's behind it. So I've stored the drag offset in a use state. I'm controlling the drag state. I'm storing it in state. This is what I'm trying to say. There's a use state here somewhere. There we go. There's a React use state that I'm just tracking the drag offset. And then I'm using this drag offset to change the opacity of the background thing. So when I start dragging, you can see like the background becomes visible. So if this is up here and I start dragging, Nitish's post slowly starts and you can see Neha's post. So it's kind of giving you a feeling that when you start dragging, if you leave it, it's going to snap back, right? So again, using motion, using animations and motion and gestures in this case to give a hint of what would happen instead of just snapping into place, because that's how most games and most mobile applications work. And we can really bring this into the web because, well, the tech is here. All right, then there are just 2 points which I want to kind of bring up before we end this talk. The first one is when you're building this kind of interface, what's really, really important is to not forget about accessibility. So we're doing a lot of animation here. We're thinking of custom patterns like this zoom in and zoom out, we're inventing these concepts, right? Where there are all these posts, you can zoom into a post. But what's really important here is even with all of these animations and context shifts, it's important to remember that accessibility is going to be important for most users. So one of these examples is using patterns that already exist. So in this case, we're using the dialog, which means hitting escape should close it. There should be a focus lock where you can tab between these states and it shouldn't go out of it. Next one is with animation specifically. When you're doing a lot of motion animations, it's important to remember that there are folks with motion sickness, there are folks with vestibular motion diseases, in which case, like the more motion you have, it makes the UI feel dizzy, right? So let me show you actually. So if I go to accessibility, so this is how Mac, like when you change screens, it slides in. You've seen this before. But if you enable reduce motion, which is an accessibility setting, now when I change the screen, I'm still doing the 3-finger swipe. It doesn't move, it only fades in. And this is a setting called reduce motion. So whenever you're doing animations, it's important to remember that there are users whose life you're making harder if you have a lot of motion, and you need to also take them into account. And again, with any animation library, you kind of have some ways to already take care of it. So with frame of motion, you get this hook called use reduce motion, which basically reads, browsers expose that the OS has reduced motion enabled, and you get this as a prop essentially, or as a hook. And we can use this in our animation. So the place where we're saying the initial Y should be a different position and animate into it, I'm going to add a condition here with like, if the user has said, don't give me a lot of motion, then I'm going to say, keep the same position as the final state. Same goes for exit. If they don't want motion, then it should not use the initial state. It should just go to the final, like it shouldn't change states a lot. So when we do this, you see that there is, in the selected post, there is no motion. I should do the same with replies. But if we still want some motion, because shading is still better, it's a lot of people who get motion sickness are, they don't get it from elements fading in, but of course you should do your own research on this. I am neither a doctor nor an accessibility expert, so don't listen to me. And I'm going to say the fade should happen for all users. So opacity 0 to 1, back to 0 and exit. But the motion of the Y position should only happen if the user does not have reduced motion. If they requested reduced motion, then it shouldn't happen. So this is how it would look for somebody who has enabled reduced motion. And when I disable it, then it snaps. And this is how it would look for them. So those are the things that I wanted to like flag that I haven't done in this application, but something that you should remember once you start diving into this. Finally, if you've already opened the link, which is this one, saturday.versal.app, at the absolute bottom, there is the repo. I have the repo link there. So you can click it. I have multiple branches for what it looks like with no motion, fade only, and the main branch is the final one. And it's a Next.js app. You can explore the code, tweak it, fork it, play around with it. It's all yours. And yeah, finally, I guess that's it. I'm also making a course, which I will not plug here. And yeah, I think that's all from me. I'm going to stop sharing now.
Thank you so much, Siddharth. That was a wonderful talk. We learned so much about, you didn't just cover the motion, it was like a beginner crash course in motion. And we also learned how simple animations and, simple user experience like that can elevate the whole experience for a certain user. And the step-by-step, it was sort of a tutorial, which helped me. And I'm hoping that it helped all of you as well. So thank you so much, Siddharth, for that insightful session. And if you want to catch up with Siddharth, our sessions tab, which is down at your screen, just press the tab, join the session with Siddharth, and you can ask away all your questions that you have for him. Our next speaker is Vivek Bansal. He is a staff software engineer at Harness, and he is going to talk about his favorite topic in the world, which is end-to-end typing. So please welcome on stage, Vivek Bansal.
Yeah. Hey, thank you, Varsha, for the introduction. Can you guys see my slides? Yeah, thank you. Yeah, sure. Let's begin. So, hello everyone. Today I'll be speaking about my favorite topic, like Varsha mentioned, typing. And the specialty in today's topic is end-to-end typing. So before we start, let me just tell you something about myself. So I work as a UI engineer at Harness. Before this, I used to work at Flipkart, and I primarily work with TypeScript and React. I like to listening to EDM music while I code, and I regularly watch Formula 1 on the weekend. Since the talk is about typing. So let's first discuss a little bit about TypeScript. Right. So TypeScript is an open source language by Microsoft. It is generally considered as a superset of JavaScript. It adds static type checking to the JavaScript and helps you detect errors at compile time. It provides predictability and readability in terms of, especially in large code bases. It is suitable for, as I said, like for large scale products like enterprise applications. Over the past few years, we have seen a steady increase in the usage of TypeScript, as you can see from this graph, right? Around 2016, the usage of TypeScript was below 25%, and as of 2020, it is nearly 75%. And many companies and organizations are slowly migrating their projects to TypeScript, and even very popular projects like React Router DOM are being migrated to TypeScript because it provides a very good developer experience. Now let's have a look at a basic anatomy of a web app. So in a web app, generally you have a client and you have a server, and there is a communication between them, and it generally happens using HTTP requests. For example, here we are making a request to a get resource on some URL. The servers then takes this request, processes it, and responds with the data. Over the HTTP layer, generally we use JSON. JSON is the most popular format. There are other formats possible, but the JSON is very popular. Right. So we have now the client side of the application, and we have the server side of the application. Using TypeScript, we can ensure type safety on the client, and on the server, you can ensure type safety using languages like Java, TypeScript, and Go. Even languages like PHP, Python, and Ruby have added static typing, just like TypeScript, in recent version of their languages. And so we can establish that server is type safe and client is type safe, right? But you see that there is a disconnect between the server and the client, right? There is nothing connecting those or bridging the gap, right? But if you are using one of these two frameworks, not frameworks actually, these are specifications, right? So one is called Open API Initiative, and the other is called GraphQL, right? If you use any of these specifications in your applications, the bridging that gap is very easy. And I'll go through each of these specification briefly, right? First, and I want to make a disclaimer that this is nothing about which is better, REST or GraphQL or OpenAPI. It is not about that. It's purely about the advantages of using either of these frameworks. So let's look at what is a OpenAPI and what is GraphQL. So OpenAPI is a description format for your REST APIs. It is usually written in JSON or YAML, and its tooling is available in many languages, not just TypeScript. Similarly, GraphQL is a query language for an API, but it has its own syntax, which is very different from JSON. And it also has tooling available in many languages. So what are the advantages of using any of these frameworks? Right? You can establish very solid API contracts between the client and the server. What that means is if, let's say, contract shape of a JSON data which you are getting changes at the backend, right? So the client would be immediately updated of that, and you can make the required changes to your application. You can also reuse the types which are defined in the backend at the front end, and no need to manually redefine those types in the front end again. API documentation can be generated automatically using these specifications. You don't need to maintain it manually or update them manually. You can also generate mock data automatically for your applications to test it, or getting your development process started pretty early. It can also help with automated testing of APIs. So I'll try to give you a brief example of each of these points in the demo, which we'll have a look at now. Excuse me. So for the demo purposes, I have created this application which gives you the data of the Formula One seasons. So this application is implemented using REST APIs and also GraphQL APIs. Both the view layer is very similar between both the applications, but it's just the communication layer is different. This REST application, as the name suggests, uses REST APIs to interact with the server. The GraphQL application uses GraphQL. So first we'll focus on the REST application, right? This when you land on the main page, right, you can select a season for which you want to see the summary of the data. All the way going back to 1950, you can actually see all the summary of the data. So you can see all the races that took place in this season. You can look at who was on pole position, who was the winner for the race. You can look at the driver standings for the season, and also you can look at the constructor standings for the season. And when you click on the constructor standings, right, so you can actually look their progress throughout the season, like how they performed race wise, right? Yeah. So similar page exists for drivers, but I have not implemented it yet, and I was waiting for this day to implement it. Right. So let's dive into the code right away. Right. So what you see here is what is a API, Open API specification. So it is you can define it using YAML or JSON. Here I've used YAML. So you can see that you can define your paths or schemas in the YAML itself. If you open a path, you can define your method. You can give a description. You can give some unique identifier. You can give what parameters it accepts. You can also define your responses, right? So this way you can establish a very good contract specification for your contract. All right. So you can also define your schemas. So these are the objects which I have defined using YAML. So you see there is a season summary, which is of type object. It has different properties, right? So this is very similar if you have worked with JSON schema itself. So they are related around 90%. They are not 100% same. They overlap a bit, but in some cases, Open API differs from JSON schema specification. This is how you define your schema in GraphQL. So this is a proprietary syntax which they have. You define your types and your query, then you define your different types available. Right, so this is how you define schema. I will not be going into details how GraphQL works. So this is just an overview, right? One thing I would like to say that Open API, it's not necessary that you write this YAML by hand yourself. There are frameworks out there which can generate this YAML for you. For example, in Node.js, there is a framework called Loopback, which you can use, and it will spit out this YAML for you. But for the purposes of this demo, I have implemented this manually by hand. Right. Let's now move on to implementing this page. Right. So let me just open driver standings page. Yeah. Right, so I have the skeleton already here. So generally what happens is when you are working on an application, right, you receive a mock JSON from your backend developer or something like that to work on and start developing your app. In a similar fashion, I have this mock JSON ready with me to test out and implement the application. So what I'll do is I'll import that data. Input data from mock.json, and I already have a snippet ready. So I'll just replace it. I'll uncomment this. Right. Now let's take a look at this. Right. Now you can see that the data is coming from the mock.json. Let me just show you by going for some other drivers. Say I have selected for Ricardo, but the data is still coming from for Lewis Hamilton because we are using mock. So now let's try to connect to an API. Right. For the purposes of this demo, I will be using a package called RESTful React. It allows us to make API calls using hooks. Right. So you generally use something like this, use get okay, I'll paste this, I'll copy, I'll paste this, I'll need to import spinner, right. Now I am on for standings for Ricardo. Let me just refresh it. Yeah, now you can see that I am getting data for correct driver, Daniel Ricardo, right? And yeah, you can see that the data is coming correctly. Now let's move on to some other driver and let's try to see whether it's working. Oh, something went wrong, right? Let's check what happened. So let me go to console, right? So we got this error saying that expected type was number but got object instead of null, right? So how can we avoid this? Imagine this happening on a production site or even on your QA, right? That would be very disastrous, right? So how can we prevent this at even during when we are writing the code itself, right? So using OpenAPI, we can do this. So RESTful React also comes out of the box with a CLI which can import this OpenAPI schema and generate some hooks for you, which integrate all the types. So when you run this hooks RESTful React CLI, it spits out a file. Sorry, this is for GraphQL. Right, it spits out a file something like this, right, where you have all the interfaces defined and these are already read and converted to TypeScript from the specification itself, right? And it automatically helps and creates all the hooks for you. So if you look at this for our driver standing, it has already created a hook which we can already directly use, and it is plugging in all the correct types automatically, right? So let's just let me just, I have even that ready. Let me just put it over here and I will import it, and let me just comment that out, clean this up. Right now you can see that since we are reading this data from the backend, right, we get the type of this data automatically populated over here, and you can see here itself, right? Like it is saying that our data is incompatible, and it is saying that the property points is incompatible. It comes as number or null, but I am trying to give it as number. I am accepting only numbers, right? So we have caught this kind of issue while development itself. All right. So let me just open this component, and let me just change this. Okay, so I'll accept number or null now. I know ahead of time that these three properties are nullable because I have implemented the code. Right. Now when I do this, right, so you can see that there are more issues popping over in your file. So I can just, I can just put in some, so this is double line. Right, position, if it comes, else I will say dash. Right. Why it is not picking? Oh, it's a raise position. Sorry. Right. Now I don't see any other errors. And now if we run this, yeah, the data is now loading correctly. And you see that this value was coming as null. And we have handled it gracefully, right, without even actually hitting the API. If we have this implementation implemented correctly, we can do this, right? So let me just go back on my slide, right? So first, I had demonstrated like solid API contracts can be enforced. So I have demonstrated this. This can be similarly done for GraphQL. Let me just show you for GraphQL also. Right, so if I switch to GraphQL, it is already working because I had implemented this ahead of time. Let me just open the page for GraphQL. Driver standings inside GraphQL, right? So similar thing can be done for GraphQL, right? So I have already created a hook for this. If you see, right, so it also plugs in the data required, the response types, everything automatically, right? For purposes of this demo, I'm using a package called URQL. URQL is one of the famous package which is used in GraphQL world. And for generating this file, I'm using something called GraphQL code generator. So GraphQL code generator. Yeah, so I'm using this package, GraphQL code generator. It supports TypeScript and many packages. It even supports Apollo. It supports Vue. Right? It supports a lot of frameworks and languages. It also supports like .NET, Java. Like you have support for different languages which you can use, right? Not just TypeScript. So for the demo, I'm using this package. Right, so this gives, so if you see, right, so I'm getting that data is of type drivers standing page query. Let me just go here, page query, right? You can see that it has done everything for you, right? So instead of doing this manually, you can do this in an automated way, and it reduces a lot of manual efforts which you need to put in testing, right? So if you are using some either Open API standard or GraphQL, either one of this with something like this, right? it removes a lot of manual effort from developers end. And I would like to also say that this is not only packages out there. For example, for GraphQL, there are other packages which I'm not aware of. For OpenAPI, there is this website called OpenAPI Tools. Sorry for the background noise. There is a railway track near my house. Sorry for that. Yeah. Yeah, where was I? Yeah. So for OpenAPI Tools, we have this website called OpenAPI Tools, where you can get a bunch of different uh, tools for your languages. Like if you see, the converters are available for TypeScript, Go, PHP, .NET, everything, right? So and Python and different languages, right? So you can adopt. It's not necessary you use a TypeScript at the backend to get advantage of this. You can use any language, but I urge you to look into this and adopt this uh, in your organizations, right? Uh, Now coming to, so you can, since the types are generated, right? So you can share them between front end and back end, and you can actually reuse them instead of writing them in separately in the client and trying to keep them in sync with the backend. You can actually reuse them, and if the backend changes, you can get those updated types automatically, right? For API documentation, I'll show you an example. Right. So, for example, this is the automatic documentation generated for the Formula One app using OpenAPI. Right. If you see that the summary which we had defined has been picked up as here as a heading, it gives all the path parameters required. It gives us a response schema, right? What it gives, right? You can go in detail and look at it. It also gives you sample dummy data. Let me just expand all, right? It also gives you a sample dummy data which you can use to get started with your development, right? If you don't like to work with TypeScript, right? You can use this to kick off your development. Right, so this is the automatic documentation. So I'm using one of the tools which is mentioned over here only for this. Next, for GraphQL also, GraphQL comes out of the box with a tool called GraphQL, which acts as the cell documentation. So if you look over here, this is a documentation explorer that comes. So you have query, you have season summary, for example. You can go to constructor standings, look at the arguments, and look at the return types, what you have, right? Yeah, using such kind of tools, right, will greatly reduce the mental burden and manual testing effort from the developers side. So I'm all about always how can I improve the developer experience, right? So this is one of the ways that I found in which we can actually improve the development developer experience, right? So this is all from my side on this. So this code is actually will be available on GitHub. You can go to this URL or scan this QR code. So this code is actually available on GitHub, and you can play with around it. And you can also connect with me on the session after this talk. And if you have any doubts or anything, we can discuss that over there. Thank you. This is all from my side.
Thank you so much, Vivek. For all of you who don't know, Vivek has been like one of the first few people in Flipkart who has established that strong typing system and who has helped us grow from there on. Vivek has always been, the pioneer in that area, and he's still continuing to do so. And I think he's talked about a lot of automated tools who can generate these API documentations and everything, so that the dev testing effort and your QA testing effort and all these type mismatches are at a minimum. So make sure you connect with him in the sessions tab, and ask relevant questions to him, and whatever your doubts are, or maybe how you can make your applications more type safe. Just connect with Vivek, and we'll move on. This is again a break time, and post this we'll have another half an hour talk, and then we'll break for a panel discussion. So just a quick break of half an hour. So do whatever you feel like. Take a quick nap and come back, join us. Again, I'd like to thank our sponsors who have helped us organize this conference today. So thank you, everyone, and thank you for joining us. Please join us back sharp at 3:30 p.m. IST, and we will be beginning with Prateek's talk on Invincible React states with domain-driven design. Thank you.
Hey everyone, we're back after our short break. We have a few more sessions lined up for today, but before we wrap up our day one and start with the next talks, I'd like to give another quick shout out to our awesome sponsors without whom this conference could not be possible. Some of them, including Hasara, are also hiring for a bunch of roles. So if you're on the job hunt, do drop by their booths in the Expo tab. All right. So next up, we have Prateek Pandey, Senior Software Engineer at Porter, who will be talking about converting business use cases into models that speak a common language, using the concept of domain-driven design. Prateek has been in the software development space for over 5 years. He is currently working as a senior software engineer at Porter. He's passionate about React and ReasonML, and these have been his primary areas of focus for the last 2 years. But apart from that, he loves to cook and experiment with new recipes. So without further ado, let me hand it over to Prateek.
Hi. Hello, guys. Good afternoon. This is Prateek. I'm a senior software engineer at Porter. And the topic for the day is Invincible React states with domain-driven design. Before I move forward, a quick word about Porter. So Porter is a intracity marketplace for intracity logistics. We connect people with their business needs through a network of 50,000 trucks. And we are also solving some personal use cases, right? Two-wheeler delivery, a two-wheeler vehicle category for hyperlocal delivery, and packers and movers for shifting needs. And we currently operate in 10 cities across India. And I work in the front-end team of Porter, where we use React and ReasonML as our stack. Okay, so that was a quick introduction about Porter, and let's get into the presentation. Cool. So the idea today is how we can convert our business cases, our business use cases to models or which speak the language of the business. In short, how we can write code that represents and is our business use cases and is quite rich as the real use cases are. How does it going to help us? It's going to help us by removing all the ambiguity that comes during a product development lifecycle, where context gets lost when things are translated between different teams in a product environment. Okay, so the goal today is to create a shared domain model that enables good design, hassle-free development, and clear communication. Let me take a very simple example. For example, we have an order management system, okay, where a request for order comes, it is processed, it's placed, then it's billed, it's shipped, and then the acknowledgement is sent to customers. So quickly in your mind, you can identify there are a lot of different areas if I can divide this whole ecosystem into. My order placement team, my shipping team, my billing team. So in my shipping team, I can call that my order is shipped order. That is what my context in that particular team would be. And shipped order will be a part of my domain model. How does it help? It helps because now when people will be talking to each other, that includes we and our code, we will be always be talking in terms of this common terminology, shipped order. And that is not the only the terminology of the talking, it will be the terminology that would be there in our design as well, as we'll see. Getting a little technical now. So if shipped, there is a team in the, for example, in Porter, which owns the shipped order system. So only those guys would be aware of how we can translate or how the data persists in the database and how it is translated to this domain. Rest, all the consumers, be the front-end team, the other teams, the product, the business, they all need to work around this shipped order domain model only. And this can evolve separately and then talk to other systems like the billing system through a properly defined interface. So that is where my shared mental model is so powerful. Okay. So let's dissect that domain-driven design a bit. What are domains? Domain is an area knowledge associated with the problem we are trying to solve. So whatever is my business case is my domain, and who all are experts, we have certain term called domain experts. So like your product or the business are your domain experts. What are domain models? Domain model is the dictionary to the area knowledge, right? So it is the common, once things like that your product development cycle starts, domain model becomes your dictionary, your shared mental model, which I just talked about for all in your team. Okay, so domain is your problem space, domain model is the solution space. What is domain-driven design? So it's an approach where the structure and language of the code talks in terms of business. So guys, this is not a methodology, it's not an algorithm, it's just the way of doing things. It's highly subjective. The only requirement, the basic requirement is when you design and write your code, your design should be as rich as your business. It should dictate the rules your product is dictating. That's the only basic thing we have to keep in mind. Okay. So all of us are front-end devs. So let us explore key triple D, which is domain-driven design. Where does it fit in our front-end? So take the small diagram which we have now. I'll just walk you through it. So we have something called a network request where we fetch the data. We have a state and a state mapper. The state mapper actually deserializes the data from the request into the state. Then we have view model in VM, and then we have VM mapper, and then we have the view. Let me explain you this with a example. So for example, you have a list of orders. Okay, these can be the trips if you imagine an app like Ola or Uber, and I have to show these orders on the platform separated by geo regions. That is the requirement, for example. Now, how do we do this? So we make the network call. We make the network call, and we have a list of orders with us in the state. Now, in view model, what we can do is we can segregate those orders by geo region using a map data structure, and then show them in a table depending on the geo region in the view. Geo regions are like my Bangalore, Hyderabad. These are the geo regions I'm talking about. So state is the domain model for my application, the front-end application. VM, you can say view model is a domain model for my view because view consumes it. So as we go through the talk, this is where state is where I'll be focusing on. Because if we model our state accurately to the business requirements, our half the battle is won. That is why you would have heard, like when we start the project, the lead asks us, or we are first to we first design the state, because we know if we can model the state accurately, we can going forward, we just need to worry about the stuff which is the writing. The writing of the code is not that difficult, but if you model your things, you understand things incorrectly, then it creates problem down the cycle. So that is what we are trying to avoid here. Okay. So I would be explaining you this process. How do we use domain-driven design through a product requirement documentation which I have created, and I'll walk you, and then I'll show you the domain model. Two things to note: the domain-driven design which I'll be showing you is functionally oriented, and ReasonML is the language of the choice. So ReasonML is a wonderful language if you want to do things functionally on the front end, along with the power of static typing. Okay, so guys, from this talk, I would want you to focus more on what I am doing and why I'm doing, how I'm doing, the language constructs, the philosophy of the framework. That is not important today. Okay, cool. The use case. So guys, we will be generating an account statement for an enterprise business account. What's an enterprise business account? So for example, your company has an enterprise account of Uber. it means that all the employees of the company can book the trips with the company account, and then once bi-monthly or at the end of month, you will get an account statement with a list exactly what is the what all trips were there, the detail of the trips, and the final how much amount the Uber you have to pay to the Uber, the company has to pay to the Uber. So we will be taking such an enterprise model in an example for which we will have to generate the account statement. This is the detailed PRD. I will walk you through it with the help of a diagram. So let's start. So our account statement. Account statement has a statement ID and a wallet and a cycle summary and a business info. Also, focus the use of my words and or. That will help us when we model the domain. Okay. Wallet. Now the customer, this is the account statement for the customer for Uber in this case. So customer wallet can be of type credit or cash. Cash is like a Paytm wallet, credit is like your credit card. If the wallet is of type cash, it has a wallet balance, a credit limit, and a credit limit consumed. If it's a cash wallet has a wallet balance. So if I talk about credit, for example, you have a credit of 20,000 rupees, you spend 5,000, so your wallet balance becomes minus 5,000 if you are a credit customer, and your available credit limit is 15,000. That's the way it's working here if it's credit. Okay. Statement ID, it's a unique string which you can identify a statement. Business info is like your name and brand name, like Ola and ANA Technologies. Cycle summary and wallet. I described what wallet is. Let's go to cycle summary. What is cycle summary? Cycle summary has a list of orders which can be placed on the business account. It's equivalent to trips. If I would say, I have a list of transactions, date of generation, the date the statement will be generated, and cycle duration, which has start time, end time, and time zone. List of transactions. A transaction can be of type credit or debit. Okay. So because when you make recharges, it's the credit. If you are paying for the expenses, it's debit. So, okay, so this was my PRD and account statement. Now, this is what is domain, which I explained you. Now, what I will be modeling is the part of domain model, the problem, the solution. Okay, so let's get here. Okay, guys, I think the screen is visible. Okay, I think the code is visible. Okay, so this is my top level entity, account statement, which has a statement ID, an account summary or the account cycle, which I say here, business info, and a wallet info. This is a ReasonML record. A ReasonML record is like any other object, but here we have keys and explicitly defined types. So yeah, we can see string is a primitive type, account cycle.t is a custom type. It is another record. So we are making our solution by composing types. Okay, and now if you see here, I'll just be switching back and forth. This was my domain. Now this is my domain model. There is some similarity, right? A lot of similarity actually. Okay, so now let's go to account cycle, and we see we have again a record which has these four things: transaction list, orders, cycle duration, date of generation. Cycle orders is anyways a list of orders. Okay. Again, so if I go here, you see cycle summary, which I'm calling account cycle. I should have said account cycle. It has these four things. Now, if I come back, okay, my account cycle, it has these four things. Okay, let's go to wallet. Now, wallet can be of type credit wallet and cash wallet, as we discussed. Now, you see something different, right? So this is what we call variant in ReasonML. Variant is like enum, which you are, I think, more familiar with, and with a payload. Enums mean you're not allowed to have payloads. In variants, you are allowed to have payloads. Fundamentally, this is OR condition. This was my AND condition. Account statement has these and this and this and this. Wallet can be of type this or this. Okay, what is in the payload? If I go to credit wallet, it has a credit limit. This is my credit wallet strategy. The credit wallet usage has wallet balance and credit limit used. So this is subjective. It is not necessary when you go and design your domain model or it looks exactly the same. but it should, as I said before, it should look exactly same as your PRD. These things are like, and there are more than one ways of doing it, as it is always with the code. Okay. And then I have cache wallet, which has wallet balance and last recharge event. Okay. What I'll also do here is, because I'm going through it, I'll also show you the final output so that you guys understand by what will I create. So something like this, guys. So this is my credit account statement, which I'll be sending. And so as we know, we have wallet is of two types. So we will have two types of statement. This is my cash account statement, which has everything. Okay, so these are this is my final output, like your front end. We are generating a PDF here using a beautiful library, thanks to those guys, the open source guys. Okay, so for example, I have last recharge amount here. Now I come back, just showing you the context. So let's now see something. Okay, let's get back here. Let's get to account cycle. I wanted to show you something. Okay, let's get to cash wallet. Okay, now cash wallet has something called as last recharge event. Okay, so the last recharge event is option of recharge event.t. Recharge event.t is another record. So why do we use option here? So option is also an inbuilt variant or inbuilt way in ReasonML to represent OR types. And what it is telling me is ki bhai, this value can be there or cannot be there. That's the nullable types which we talk about in general. So, and this satisfies my business case as well, because if there is no, for example, recharge in the cycle, this event can be null. There will be no last recharge event kind of sort of things. So this is like my domain speaking to my business, another example. And someone who is consuming this domain, be it the front end, the view, or even any other service, they will know that this thing we have to handle. For example, right now, this domain model is more for my view, the React view. So the front end will know, okay, bhai, either last recharge event is optional. It means we will have to handle the case where the value is null by using something like an NA instead of the actual value. And this is where we can handle errors which we have seen in JavaScript. So you would have seen errors like null of amount not found. So because you were expecting that null, but it came null, right? So those things, like your code is speaking to you. Bhai, I have already taken this thing into account. My business has taken this thing into account. So let's take this into account in our code as well. Okay. What else is here? Okay, this is interesting. So this is my order type. Let's come here. So again, you see that, okay, this is again the variant. Okay, the OR. So I knew that my order can be of these five, can have these five statuses that I knew from my business. It can be open, accepted, live, completed, cancelled, like a trip, the way you book your cab. Same terminology. But we knew ki, for example, when the trip is of status completed, it has certain more information, started time, end time. And we know that this information should only be present in our state if the value is completed. Matlab, if the order is of type open, status open, you cannot have this value. So when you go through a state like this, you can understand, okay, so I have my business case and I have represented it here, and it is same way as the product dictates. Okay, don't worry about how you are going to consume it, or when we write code, or when we actually put this value into view, how are we going to use it. That is not relevant right now. Right now, what is relevant is we are baking in everything we know from the PRD. Your product manager has spent a lot of effort preparing that PRD. He has talked to a lot of people. So as when we are doing this, we are also putting in that effort, which I mentioned in the beginning, that your domain model should be as rich as your real use cases, if not exactly rich. Okay, sorry, coming back to the original discussion. One more thing. So this is another way of representing data. Okay, let me show you one more thing. Okay, So type T is equal to list of cycle orders or T. This is telling me that I can have a list of orders in my system. Okay, fine. You told me I put it like this. Now, list of orders means that the list can also be empty. I think if I missed, so account statement should not be sent if no cycle orders are present. That is what my PRD says. This guy is telling me it's a list which is okay, but this domain model also saying I'm okay accepting empty orders. Does my PRD tells me like that? No, right? So this is the mistake which I did during my execution of the project, and I think if Shashank and Mani are there on the call, they'll relate to it. Shashank is my product manager and Mani is my backend counterpart. So this I discovered when I was doing the final testing and some things like that. So ideally, I should have modeled this as a non-empty list. I don't have a code here because I'm still figuring out the best way to do it in Reason ML. But the point is that these subtle things can make a very good difference when you actually deploy a code. Okay, especially when there's a data set is quite big. Okay. Okay. So I think you guys got a hang of it, what we are trying to do here. Obviously, I have just scratched the surface and there is a lot to do. And we are figuring it out, but it's a good start. And the way of, if we represent our data the way we are doing it, we get to know our product inside out. So I'll be just walking you through some of my key points here. So which I was talking about, better product ownership from developers. So you imagine you are going through the PRD, which is something which is not there in PRD, or asking people around. So when you end up creating your domain model, you end up in a better position as the owners of your product. Okay, and this was the React state I was talking to you about. Everyone talks in one language. We already know we will always talk in one language. If I say order status, my product guy says order status, the business says order status, everybody says order status. And that is when my code says order status. And that is the goal. Cost of change is minimized. Yes. Now, if something changes, now there is a very good use case. I have this domain modeled here, but my view wants to change because there is a lot of ways you can represent data on the UI. Sure, you go and change your view, but we will never change my state. I was fetching data from one API. Now I have to fetch it from 6 APIs. Does this change? No, maybe the way we handle the APIs, make the API calls, put it in the store may change, but my domain model will never change. So that is what I meant when I say cost of change is minimized. API integrations are frictionless. If your domain is well thought, you can integrate very quickly. Like I was able to do the API integration from my PDF account statement, which I was generating within half an hour, barring those two, one thing which I told, like cycle orders were empty list, and one or two more things which we should have taken care of while we develop API contract. But they are frictionless. And we all have had that experience ki we are doing API integration, then we realize, array, this data should have come like this. Oh, the model should have been like this. Oh, I was not even supposed to send you this. Those kind of things, when they happen in the end, it's really bad for the development cycle and for the product as a whole. Documentation is in the code. Yes, documentation is in the code. You don't need any extra documentation, because if you're looking at something like this, you know what is there. What are even the use cases are baked in here. And this is very helpful because we all know, we devs and the product, nobody lasts the full life cycle of a product. Very few people last. So if you have a code like this, it's actually helpful. And guys, so I think one more thing which I would say is that these things, especially domain-driven design, the way to do it is obviously read your PRD well and start designing. You read, you implement, but you discuss also. Discussions are a key part of the way when you do things this way. And whatever I'm telling you, a big part of this is my review comments, the review comments on my design. So discussions are a healthy part until your design is freezed. You talk to everybody, not just your tech. The way it's obviously different in different companies, but it's very essential. Okay, so I think you guys took something out of it. it's not easy to come up to this point of view. I'm speaking here but I have done I've 1.5 years I've been doing things this way, and so it doesn't happen in a day, and it is not for everybody. This is very helpful for enterprise applications, may not be helpful in other ways, but it's worth a try. So I was grateful to this book, Domain Modeling Made Functional by Scott Volashin. Wonderful book. Blush and Endraw. So if you saw these people in my slides, these are created by Blush, thanks to Pablo and his team. It's a wonderful illustration product. The wonderful folks at Reason who create and support ReasonML. ReasonML, still you don't find much question and answers on Stack Overflow, but we have a wonderful Discord community which helps us, and the amazing team at Porter, without whom this talk would not have been possible. A special thanks to Shubham, my colleague and mentor, who helped me come up with this. So, and special thanks to Kiran and Kamlesh for giving me the opportunity to speak, and to all of you for taking half an hour out of your Friday and coming and listening to me. So I would like to close my talk with this. We all know legacy code is bad. It's kicked around. So I ask you, what kind of code would you want to build? Is it a legacy code which people stay away, or it is a code which you are proud of, and when the people who come after you work, they also find it equally entertaining as you found it? Okay. So thank you all. Hope you have an amazing day. Bye-bye.
Thank you so much, Prateek. That was an amazing talk. I've always been really interested in the concept of DDD, and I've always wanted to learn more about it. And I think your talk is, I'm going to add your talk to the list of resources that would come in handy when someone wants to learn about domain-driven design. So that's definitely something that I'd love to, that's definitely a talk that I'd love to go back to sometime again, full of information. And now I think we can take a short break, but we're also trying to see if we can accommodate a couple sessions that were having technical difficulties earlier. That was Nitish Fanse's talk and Dane's talk. So I'm actually waiting on Kiran to let me know if we can accommodate those talks. So please bear with me for 2 minutes. Otherwise, we are going to break out for another short break. But before that, in the meantime, let me remind you about the giveaways. So since you'll be learning a lot from the conference in these 2 days, we'd love to hear about you, and we'd love to know what all things you found interesting, what all concepts you learned, what things you're excited about. And we've dedicated the hashtag TIL React Day India. So please make sure to use this hashtag to share all your learnings and mention us at React Day In. Also, tweet your fun screenshots again with any speakers, MCs, co-participants, any cool moments that you see during the conference that you had fun with. Please share those pictures with us using the hashtag FunReactDayIn. And these are the activities that you can participate in to get a chance to win some cool goodies that we're giving away during React Day India. So you can also visit the expo and check out the sponsor giveaways that our lovely sponsors are doing. And as I said earlier, some of them are also hiring. So please don't forget to check out the sponsor booths and drop by their booths to see the open roles that they currently have. Giving a huge shout out to our sponsors: Archimedes, Atlantis, Auth0, ClearTax, Geeky Ants, GoIBbo.com, Grow, Harness, Hasara, Disney Hotstar, Open House, Column, Razorpay, Swiggy, and Exactly. Without them, this conference would literally not be possible. Thank you so much. All right, folks. Thank you for being patient with us. We're back with Nitish's talk. Nitish was having technical difficulties earlier this morning, so we decided to allot this time to Nitish so that he can give his talk again. So let me welcome Nitish, a senior software engineer at Myntra, who will be talking about thinking of UI as a state machine.
This is part 2 or take 2 of my talk again. Before I get started, a big thank you to Kiran and Kamlesh and the entire React Day Bangalore team for organizing this entire event that is there. Doing something from a remote as a remote conference is extremely difficult because communication is async, and they've probably been extremely forthcoming and warm in the entire process, and it's been a very comfortable feeling. So we tried this in the morning, didn't go out as expected, had some internet issues probably on my side. I realized the chat is extremely hilarious, and there was like a riot on the chat, and there were a lot of funny quips and messages on that. So there's a good prospect for if people want to consider roasting people as a as an alternate option. But yeah, having said that, let's get started with my talk, which is on a thinking of UI as a finite state machine. So a little bit about me. My name is Nitish. I work at Myntra, and this is my Twitter handle. You can follow me here. And I talk typically around things around JS, around interfaces, a little bit of React, around cricket, recently on Golang, and also a little bit of chess. So right, we come to the point of what is an FSM or a finite state machine. Now, for someone like me who was from a non-computer science background, this was an extremely hard thing to grapple because this was something where I had no idea of what it was. And if you're someone who's probably worked from in a backend ecosystem, you will know what this is because backend architectures do tend to use this. So as always, like everyone does, the first thing that you do, you probably look at Wikipedia or something like that, and Wiki has like a definition which is along these lines, right? So it calls it a mathematical model of computation. 3 words, as I said, if put together make no sense, and then below that there is some formula that they've added where they say that finite state machine is a quintuple with some Greek alphabets inside it. Prior to this this thing of knowing what a state machine was, I didn't know what the word quintuple meant. So that is like a new learning as well for me in this case. So I decided to probably go in with a approach where I can come up with my own definition of it, which is probably easy for people to understand and read. So this was my definition of it, where I can call it like an object in memory which stores the state of an entity and handles its transition from one state to another based on certain events. So you can think of it like an entity which you can be in your daily day or any daily day use, and you have possible states to describe what the entity is. And a state machine will handle transitions from one state to another based on events. So just throughout this talk, if I mention the word state, I'm saying the FSM state. If it is explicitly like a React-based state, I will call it as a React state. So let's take the daily example of a bulb, right? You have a bulb. There are 2 possible scenarios that can, or 2 possible states that can describe this bulb. One is an off state, the other is an on state. There is nothing other than this which can describe what a bulb is. A bulb exploding is like a altogether different case, but in a normal utopian world, you will have 2 possible states for a bulb. You have an event that you pass or that occurs on the bulb, which is say turning on, which can be you turn on the switch or you press a button on a remote, and it changes from an off to an on. Similarly, you have another this where you press it and it goes from on to off, and This is something which can be encapsulated, or this entire bit is something that we can call as a finite state machine. So there are finite states of the entity of a bulb, and other than these two states, there is nothing else that the bulb can represent. So it is a very deterministic behavior of an entity, which is the bulb here, where it can be either off or on, and you can turn it on or off based on the two events that come. So if you look around you, there are a number of events that, there are a number of entities which can follow an FSM sort of a pattern. You have your microwave, you have a lift, probably some of the things that you use in daily lives can be used as FSMs, right? Or they follow the FSM architecture. Now, most of us, I'm assuming here, do work in P2C sort of products or product-based companies, where the end goal of whatever you're building is to do a transaction. It can be if you're in an e-commerce company, it is the user places an order and then it gets delivered to him. If you're in a company that is delivering food online, it can be something which places where you place the food and it gets delivered. Right. So we take the case of a food delivery, the journey of your entity, which is your order here. So from order state, it goes to, say, an order preparing. Then you get a this that yes, food is prepared. Then you get like yes, I have dispatched it. Followed by you get the idea that yes, it has been delivered. Now in this entire thing, you know that at any given point, whatever state your entity is in, you know the next state, and based on a certain condition, it will only go in one direction. That is, in this case, from food is prepared, it cannot go back to order is placed, or say dispatched. From dispatched, it cannot go to preparing. In a normal scenario, like a very simple, linear situation that I'm considering. So if we had to think of what the definition of a state machine is, you can think of a like something which has two states, or an object which has an entity which has multiple states, and then based on an event, the entity decides, do I need to go from one state to another, and this is called as a transition typically within the state machine. So there are a couple of mutations that occur inside the transition bit, which is an on exit and an on enter. So these can be callbacks where while I exit from state one, execute some certain handlers, and while I enter into state two, execute certain handlers. So this is one thing where you can see that state is not the same as a state machine. So here now when I say state, I am talking about the React state. So React state is what defines your application, the data, the way you the way you show the view layer, or the data that powers the view layer is your React state. State machine can be something which supplies that bit of the state to your React state, right? Or it's like for a person who doesn't know what a state machine is, it's like a black box which tells you based on certain events what the current behavior of a certain entity is. Right? Then next we come to the bit of why do we need to use state machines at all? Do we really need a state machine? Are we overcomplicating things? So state machine is something that is without us realizing, is a common language between developers and designers, and this has been there for a long time. So when your designer, makes mocks on, say a Miro or an InVision app, it knows that yes, that if I click this particular button, you show this bit in the UI, or if I highlight this bit in the button, you show something else in the UI. So this is nothing but this is the behavior of it is fairly similar to a state machine that is there. And as I said, it's a common language because a designer gives you one particular mock, and then as developers you're left to figure out probably all the possible cases, and then you end up writing conditions in your code. But if you have different states for an entity, for an input field or whatever, like in this example, like suppose you have a certain set of input fields where in an idle state there's nothing written there. When I start typing, the button becomes green. When I make an API call, there's a label above, and say on failure it becomes red, something like that. Right? This behavior is very similar to what a state machine can be. Like you can define states for these input elements at the side. So what was the use case of our state, or why did we think of a state machine, this in the UI, implementation in the UI, right? So what we were trying out in our some of our warehouses was interacting with hardware readers, and these hardware readers typically send socket events to the browser, and this implementation of this talk is typically around the browser implementation of the UI that we had done. So we had a bunch of socket events from the hardware reader which would give us certain data points. Then we had things where there were internet events like disconnections, then hardware events like disconnections. And of course, for any application to work, you also need API calls. So API calls is something that you need, as I said. And with the API calls comes the case of, if the API call fails, do I have an error mechanism? Do I need to have a retry? Do I need to have an auto correction? Now, all of this was made in some of the warehouse applications, which are primarily designed for operational efficiency, where the output or the net goal of it is something which increases operation efficiency and is not very cumbersome for the user to consume. So the case here is that while an API call is made, if I get certain socket events or if I get some disconnection events, how do I handle it? What happens? And as a developer, yes, for you, you will understand that, yes, okay, disconnect the reader and connect it again or whatever, or disconnect some ports and run diagnostics again. But for someone who's working at a warehouse, these are not very helpful messages, right? So which is why the whole idea of an auto correction and retry mechanism and things like that came, which the state machine did help us analyze and implement. So let's say we have an entity which is in a state of S1, and you have one event called E1, event 1, and it sends some data. So typically these events, when I say, can be of various types. It can be a click event, it can be a post message, it can be a socket event, it can be a browser-based event, it can be a custom event that you dispatch. It depends on how you define it. And this event has some data associated with it, and I have one state S1. So I'll typically have one handler to handle this event, right? In general, like you have a on click that you do, you have one click handler for a button. If I have the same entity in 3 other states or 2 other states, so S1, S2, S3, and the same event has to be handled differently in all of them, then you will see like, okay, fine, fair enough. I have 3 different states, so I can have 3 different handlers. This thing becomes like a M cross N problem, and automatically, if you have another event and more states, you can have 10 possible handlers. So one way is you have a nested switch statement where you have a switch first on the state S1, S2, and then inside that a switch on the event, which is actually a very verbose way of writing a finite state machine, and ultimately that is what it actually does. So this approach was something where we thought that yes, we can probably try using a normal FSM implementation where this handling of events is done out of the box, and my UI does not know what event handler is being called, but the state machine knows, because that's what the role of it is. So designing something or architecting something, we thought we'll keep it configurable. That means given a certain set of conditions or configurations, I should be able to reuse it. When I say reusable, it was not isolated. It was isolated from frameworks and wasn't, say, exclusively built just for React or for Vue or Angular, so that if I have to reuse it in another place, I'll be able to do that. Easy to subscribe to, when I say it's easy for anyone to use the API. So the components using this could have a subscriber mechanism which could use this and listen to events and then act accordingly. So we decoupled the state, the React state of a component from the state machine state of it, purely because one was separation of concerns. But if you want, you can also club the two and have like a use state machine hook which does that, which I've explained in the slides later. So let's assume you have a UI like this. The thing on the right is your UI. You have an events channel. which the state machine is listening to, and you have a subscriber bus to which the subscriber is connected to. And you have events coming in, which can be a click event, a scroll event, or a socket event, whatever. It goes into your event handlers based on the current state. It decides what to do, and assume this event was something that, yes, you have to change the current state to S2. This message is propagated to through a subscriber bus, and the components that are listening to it can make an update in its React state, and then the view gets changed. So if I have to say maintain a definition of what the state machine is, it's like you can think of it as a class. I like the object-oriented sort of approach that is there with this thing. So I prefer to choosing a class, and you have an initializer at the top, followed by the events, the type of events. So there are two types of events that the state machine propagates. One is a transition from A to B, and the other are custom events, which are typically for any mutations that you want to do. So ideally, it's recommended that you do not use much of the custom events, because you can get into certain bugs or random changes which were not expected. But it's something that has been made available in case you have to. Handle event is the main handler of the state machine, where you say that yes, this is the event state machine. You do your magic and tell me what to do, and if there's a state change, propagated to the component. Dispatch event, as I mentioned, is a simple dispatcher. And then transition to next state is the main state, where if explicitly you want to transition the state machine from state 1 to state 2, you're able to do that. So just coming to the definition of what these methods are. These are fairly simple methods. I will explain what the current state context is in an event, and it just picks up that particular object with that event name and executes the function associated with it. Similarly, for dispatch event, this is a listener, a list of listeners that you subscribe to. They just get called and it gets pushed. The callback gets executed. Then we come to transition of next state. So this is the state where the method which actually transitions to the other state. So you have three parts here. One is a validation. So this validation is something where when you define your state machine or the config or the schema, as we call it, there's a validation that, yes, allow it to only go from state 1 to state 2, or by this thing. Do not let it go in a reverse way, so that if there are any errors due to random state changes, they get caught here, right? Then there is the actual transition that happens, and there is an on exit at the top. Then there is a broadcast to all the guys listening, and then there is the on init of the next state. So this is just wrapping all of it together. You have your validations, your actual transition that is there, and notifying the subscribers who are listening to it. So here I am taking the case of it's just this example called it's a ride sharing app or ride booking app, right, that you have. So there are typical, this is like a bare bone implementation, which I think is good enough to explain this concept. So you have certain states, and these are something which you can make on a paper and pencil as well, right? So you have to, if you have to define the journey of your booking an app, or booking a cab in an app, it will be something like, say, you have a trip requested, which will go into a loading state for an API call. It will, if the payment is, if the API is successful, go into a payment requested. If that is successful, it assigns a driver. If it's not successful, it goes back up to trip requested, right? Fairly straightforward, simple definition. So now if you had to explain this as the schema or as the state machine, right? So we have a config, or these are the events: trip requested, loading, payment requested. And there's a default state at the beginning, which is like the ideal state. Ideal state when you load the FSM, right? Then there comes the case of if I have to define certain events for them. So I have only taken the case of the trip requested and the trip loading case for the sake of simplicity. So here we have, say, some events here which we define inside the trip requested, which is on click. So there is an event handler for trip requested in the trip requested state. There's an event handler for loading in the loading state. Similarly, for on message, there is another handler. And then there is a set of allowed transitions. So allowed transitions is like, as I said, the fallback or something which does the validation. This entire bit after this object is what I call, or what we call as the event context. So the event name is loading and the event context is the entire object that is associated with it. Right now, what exactly, all right, so this is something where if you have a large number of events, this is something which can tend to grow, but you have all your event definitions here and their respective handlers for that particular event. And if you look at it, what are these handlers? These are nothing but just objects, JavaScript objects with those methods defined. So I will just get back to this bit a little later. So the first thing after this is how do I use this in the React app? Like you've mentioned the entire thing of what a state machine is and how do I implement it, right? So how do I use it here? So you have this, so you can initialize, because we decoupled the state transition from a React state. You initialize it at the top. Then you have the component subscribing it to transition events, and you pass down the current state down, as a prop, or you have multiple components subscribing to the same thing, same state machine, or you can have a context API which passes down the value via a consumer. So either of these approaches works fine, depends on your use case. So if you have to do it as a class-based approach, this is purely for the sake of the demo, where you have a instantiate it at the top, and then you add certain listeners. You have a remove listener for cleanup, and then you have certain callbacks that you add for updating the state. Adding it inside an on-click event is you have on-click, which is probably passed down to a button. Which is passed down to a button, followed by you tell the FSM that yes, here handle this particular event for me. Now my UI does not know when I say handle event which state it is in, what it is in. It just says that yes, handle the event. The state machine does the required bit. If there are some changes, then it will propagate it via the listeners, the subscribers, to the component. Since this is something where if you want to tie it directly to React and you have to make a hook out of it, this is what something that you could do, right? That you define a ref with state machine and you have a current state which is empty. The callback, you can add a callback which does the handle event of it. The subscriber here, and then a use effect which will add a listener and then also remove the listener as part of the use effect cleanup. So if I had to use this in my component, the code drastically reduces. It's just that there is one on-click and you have a handle event, and that will automatically, if the handler deems that a state machine transition should be made, it will get propagated into current state, and you should be able to see the changes happening here. Right? Now we'll just go back to the handlers that I had defined. So the trip requested, if you see, handler has an on event. Method handling, and here you can make your API calls, you can make transitions, you can have your error handling that you can do, you can push it to another state. Similarly here, if you see on message, the handler is empty. So what this means is that when this handler is empty, if I get an on message in the trip requested state, right, it will not be honored at all. It will. So this is how I won't get bugs from other asynchronous events in this particular state. Similarly, for payment requested, if I had to make an API call and then based on some value go to say state A or state B, you can make that transition. The driver assigned state does not have a on event or a button click here. It has in fact another event called complete click, which will do the transition here. So if I make the button click that I was doing in the earlier states in driver assigned, it will not honor it, and that event will get handled accordingly. Trip cancel is something which has an event defining. When you define an on event click, it will transition to the next one. So from what this entire thing, from what I'm trying to explain is, each state has certain event handlers, and the state machine decides what is the event handler to be executed based on the current state. And inside these handlers, if there is a transition to another state, then the respective components that are listening to it get notified. So this is a small demo which I had prepared for the sake of this thing. So say we have, so this is like the same Uber sort of ride sharing sort of a thing, right? So I've hooked it up to a socket message which sends a socket message. So when I do book trip, it goes from trip requested to a loading state where there's an API call made, which on successful goes to payment requested. Now it's the same button that I'm clicking and the same event, but because it is in another state, it is handled differently. So in this case, it is handled with get your payment details, which say if they were successful, they get assigned, a driver gets assigned. Now at this point, say I get a socket message, right, which I've handled. In this case, the trip gets cancelled, and that same button that I was using, if I call this, it goes back to the trip requested state. So this is a very deterministic behavior of the UI, and other than the ones that I've defined for the same set of events, I'm able to handle the UI or the state in a different way. So let's say there's another, this where I say do book trip and say get payment details. If this is successful, driver assigned, I do an end trip, the thing ends, then the same button says give feedback, and then again it goes back to the book trip state, right? So again it goes back to this particular page. So yeah, this was it. Then there is the entire concept of this state machine has been defined really well in this thing called xstate.js, and David has made a fantastic library out of this. And we ended up doing our own bit of it because there were some parts that we needed, so we ended up implementing part of it on our own. But if you want to get started with state machines and implementing it in your UI, this is a good starting point. There's a very good YouTube talk of his on how they use CSS attributes, style attributes for dynamic, for giving style dynamically. That's a nice talk that you can refer to. Having said this, what went well for us, right? This was like an experiment, a POC that we tried. What went well? So structuring code was easy. The model that we made to define the UI became extendable, transitions were easy, and it became extremely deterministic. It was easy to add recovery and error mechanisms in the UI, and this coupled very well with our whatever requirements that we did have, right? Of course, there were some learnings which we could have done, which probably we could have done better, but some of the learnings were that this is a hard concept for someone to grab in the first go itself, and it can be something pretty taxing for someone. And there can be a case of a state explosion, as it's called, where currently you have 3 states and they're all interlinked. Now, if you get a 4th state into the picture, what happens? Do you have a transition and communication between all those 4 states, or what is it? For this, there was a solve where you have something called a hierarchical state machine, where you have hierarchies, or a sub-state machine, and you give hierarchy to your entity and then solve it accordingly. So just in general, for the state machine part of it, right? I'm not saying that you should implement it right away and change your application to it, but if you start looking around, you'll start seeing a lot of UI components which follow this pattern. Onboarding screens, checkout processes, form elements, payment transaction pages, search input fields, all of these, if you define it and you need deterministic behavior here, the state machine approach can be something that can be helpful. All right, that was my talk. Thank you very much. I hope you guys enjoyed this.
Hey, thank you so much for that talk, Nitish. And also thank you so much for taking out the time again to join us to give that talk. So that was very informative and very insightful. Wonderful talk. Thank you so much. Now I think we have some more time before we can take a break. So I'd like to squeeze in another session that we weren't able to do because of some technical difficulties in the morning, unfortunately. So this is a talk by Dane David on failing gracefully, error boundaries in React. So I'd like to welcome Dane again on the stage to give his talk.
A full stack developer from Big Binary. I've been working with React and JavaScript for the past 4 years, and today I'll be speaking about error boundaries in React. So what are error boundaries? Error boundaries are React components that catch JavaScript errors anywhere inside their child component tree, log those errors to your servers, to your server logs, and then display a fallback UI, which might show some helpful info regarding the error, a, a symbol, graphic, maybe your branding, and even a way for the user to get back to the previous state. Technically, an error boundary is a React class component that implements either or both of the lifecycle methods to get derived state from error and component get catch. They can be used to wrap entire trees, the whole application, or individual sections of the application. Let's take an example. This is the UI of Facebook. As you can see, the stories are shown in a separate section. The messenger is a separate section. So if a story was to throw an error during rendering, you don't need to bring the whole application down. Instead, you can wrap the story section in its own error boundary, the messengers in its own error boundary, and the whole application in an error boundary just in case. So here we have a simple error boundary component in React. As you can see, both the lifecycle methods get derived state from error and component get catch are defined. Get derived state from error returns a state error true, which leads to the rendering of fallback component inside the render method. And inside component get catch, we have logged the error to our service, which is Sentry in this case. And we can use a component like this. You just have to wrap your component tree inside error boundary. Now let us see error boundaries in action. Alice tried to sign up at Acme Industries and without knowing that there is an error with the image upload flow. So when she tries to upload her image, boom, the screen goes blank. So this is clearly undesirable and can be fixed with React error boundaries. Now let us see how this works. Rendering phase has its own advantages, which are in the rendering phase has its own advantages, which are it is server-side friendly because there is no commit phase in the server, and it is safer than commit phase recovery because in commit phase recovery we have to rely on an intermediate commit of a component tree of null components. Also, state updates from inside commit phase life cycles tend to trigger synchronous re-rendering, and thus there is no forced sync re-rendering if we were to do the recovery from inside rendering phase. Now this is the flow that happens in case of an error with an error boundary. Your component renders, it throws some error during rendering. The get derived state from error lifecycle of the nearest error boundary is invoked, it updates the state, it renders a fallback UI, and then the component catch is invoked, which logs the error to a server. Error boundaries can catch errors that happen during rendering, inside lifecycle methods, or even inside constructors of the whole tree below them. They do not catch errors that happen inside event handlers, asynchronous code. They are not supported in server-side rendering. And of course, errors thrown inside the error boundary itself will not be caught by it. Now, to showcase the flexibility of error boundaries, I have created a dashboard application with many widgets. From our discussion previously, we know that each widget would be typically wrapped in its own error boundary. So if one of the widgets were to break, you can show the fallback UI instead. Break for some reason. Now this is clearly undesirable UI from the user's perspective. Most of the dashboard is broken and still he has to see a number of fallback UIs. Instead, it would be better to bring the whole dashboard down. Now, I was able to hack up a bubbling mechanism that using two error boundaries that communicate with each other using the React Context API. So if more than a threshold number of error boundaries are invoked, we can bring the whole UI down like this. Let's look at the code. As you can see, the dashboard is wrapped in its own dashboard boundary, and each widget is wrapped inside a widget error boundary. The dashboard error boundary keeps track of a child error count, which keeps track of the number of child widget error boundaries that were invoked. And this number is incremented from inside the component cache of widget error boundary. And you can see that as soon as the child error count increases the threshold, we throw an error from inside the child error boundary, which causes the parent error boundary to render the fallback. Now, before I conclude the talk, I would like to talk about a very useful library called React Error Boundary. It handles all common cases where we would typically need to write our own error boundary. It exposes three APIs, an error boundary component, an HOC, and a use error handler hook. The error boundary component is what you would expect it to be. It has three props to specify what to show as a fallback. It has a fallback component, a fallback render prop, and a fallback prop in tandem with the Suspense API. It also gives you an option to reset the error boundary and remove a child that was before there when the error happened. It also has callback props on error and on reset. For example, what you would typically write inside component catch, you would want to write inside on error callback. It also has an HOC version which accepts almost the same props, a fallback component and an on error callback. It also exports a hook called use error handler, which is pretty useful. Earlier, I talked about error boundaries not catching errors that happen inside event handlers. This is because React doesn't need an error boundary to rescue the UI from an error that occurred inside a event handler. It still knows what to render. But in some cases, especially when you have a good fallback UI already in place and you want to explicitly let the user know that something went wrong, it would be preferable if you could show the fallback UI even inside errors inside event handlers. We can see this in action. As you can see, both buttons break the UI. Both buttons throw errors on clicking. But on clicking the first button, this is an unhandled version. And even though the error is thrown, the user is confused as to what happened. And he's not given any explicit feedback. But using the hook from the React Error Boundary library, we are able to invoke the nearest error boundary component and show the fallback UI. It can also be used directly by passing in the error objects that is returned by data fetching libraries like Apollo. If the error object that is returned by Apollo has a truthy value, it renders the nearest parent fallback UI, and thus you can invoke the fallback UI without having an actual error during rendering. So with that, I would like to conclude my talk. I hope that by now you might have realized the importance of having fallbacks in anything. So use error boundaries and provide better user experiences to your users. Thank you.
Hey folks, after that amazing talk, we are ready for another short break. So you can just go and grab any beverages that you want or any snacks, and then also take a round of our expo. Also, if you'd like to connect with our speakers, they'll be hanging out in their sessions tab. So don't forget to do that. Also, our sponsors, Colum and Hasra, they're hiring for a bunch of different roles. So if you're looking for a job and if you're interested, then do check out their booths. They'll be hanging out there and they're also having some amazing discussions there. So now I think we're ready for a short break. We will be back with you at 5 p.m. For a panel discussion on web performance. Prateek Bhatnagar will be moderating that panel, and Pavitra, Rahul, and Ankit will be joining us as panelists. So, yeah, see you at 5. Hey folks, so we're ready for our final session of the day one at React Day Bangalore. So we're going to have a panel discussion on web performance that is going to be moderated by Prateek Bhatnagar. Prateek is an engineer at Uber, and we have three panelists joining him for the panel discussion: Pavitra Kodmar, Rahul Davani, and Ankit Mehni. So I'd like to hand it over to Prateek without further ado.
Hey everyone, thank you, Vishwa. Hello to everyone watching this live or trying to catch up on a recorded session. I know this is the last session, so we'll try to keep it a bit interesting. And while we'll take a lot of questions on how to improve the performance, how to make your websites faster, there are a little bit of alternate questions of what exactly performance means to different people, or what kind of performance measurement is there in different kind of apps. So without delaying this further, let's add the panelists. First up is Ankit. Can we add Ankit? Ankit has recently transitioned to a tech lead role at Flipkart. Hello, Ankit. Okay.
Hello,
Next is
everybody. How are you doing?
Pavitra. Hey, can we add Pavitra?
Hello.
Hi, Pavitra. For everyone who's watching, Pavitra is a front-end engineer at Atlassian and is writing code which a lot of us are using in everyday life, whether developers or not. Okay, then comes Rahul. Can we add Rahul?
Hello.
Rahul is a senior software developer at Swiggy and is taking care of consumer side products and a lot of Swiggy goodness that we every day interact with. Hello to all of you.
Hey.
Hey. So we have a lot of interesting questions for you guys, and like we have been talking to
And
people,
hot takes.
taking yes, and hot takes. Yes, we have gathered these questions from Twitter and other sources, but yeah. So actually, I know Pavitra is going to give a talk tomorrow at on new age bundlers, like I guess White or Snowpack, right? So our first question is actually related to it. So for a very long time, we all have been using Webpack, Rollup, and recently Parcel as well. But very recently, a lot of new age bundlers have entered the scenario. We have seen Wheat, we have seen Snowpack, and we have seen ESBuild. And I know that a few of you guys have been directly working with them or trying to have work with them and make get more and more insights for us. So starting with you, Pavitra, like what do you think, how do they scale up against Webpack or Rollup? Do they build really small websites, or are they really fast in comparison to these bundlers?
So, yeah, so giving my thoughts around this is basically the new age bundlers uh, are not aiming to replace your production build. They are aiming to make developer experience much better by making it much faster and leveraging ES modules. So, for those who don't know, ES modules came in ECMA's script 2016, I think, and what happened there was now JavaScript finally has module system, which it didn't have for 20 years, right? And the innovation that's come out of it is to have bundles, is to have files loading on your developer instance, uh, single files loading through ESM, and not your whole bundled files. So for anyone who's been using Webpack or Rollup for some time now, or on reasonably large applications, they are dev must be suffering, right? At least I'm facing that issue, that dev is really slow, and it does not need to be. So that's what. So all the new age bundlers are just built on top of ES Build. So ES Build was the first innovation in this area, and it combined two things: using ESM, having a lot of constraints in what it builds, what it does not build, and what plugins it accepts and whatnot, and using a language other than JavaScript for building itself. It's written in a language, it's written in Go and not in JavaScript like we are used to in most tools. This comes up with a lot of trade-offs, but the speed gain that it gives is so amazing that yeah, a lot of other people have jumped on top of it. So what Wheat and Snowpack are doing is almost identical. There's small differences. But what they're doing is they're leveraging ES Build for all your developer experience, and then leveraging a roll up for production bundling. Very soon you might see like Webpack support also might come in. So we can't send hundreds of files to our users through ESM, of course. So we need to send them bundle stuff. So that will remain for quite some time. But yeah, what they're aiming at is improving developer experience by making things super fast.
Right, that's a very clear,
But
crisp
but
explanation.
I have a question for Pavitra, then counter question. So I understand that these make it really fast, but don't you think that having a difference in dev setup and production setup could lead to a lot of bugs, like it works on my system, but it doesn't? And I'm not sure how the interop story is, because there are a lot of modules that are published as CommonJS, and the interop story within CommonJS and ES modules is so difficult that if you see a lot of stuff relies on underscore underscore ES modules flag. And so that I want to know how good is that support?
Yeah, so that is one of the primary challenges of Snowpack. ES Build does not care about that, but Snowpack, what it does mainly is convert all your ES modules from your Node modules, all your CJS files from Node modules, and make them into ES modules. And there's a podcast that the creator of Snowpack did, where he explained all of the challenges that he faced. But mainly, yes, the problem is that what we have done up until now is we have browserified Node code. But with ES modules coming up, we are now trying to like only support ES modules, while it is completely different from how CommonJS behaves. Yes, that is one of the primary challenges. About the dev setup being different from prod setup, well, it is kind of different even with Webpack. At least that's my experience right now. My experience right now is that even though I use Webpack for both dev and prod, my dev Webpack is completely different. There's a lot of things that I don't do in my dev Webpack, some chunking, some minification, some source maps, so many things that I don't do, and we are still managing. I think that should be managed at like your canary or those levels with your integration tests and stuff. Yeah, I don't think it's that strong of a problem that your dev and your prod are different. It already kind of is, in my experience at least.
No, I'm just saying because we were bitten by this bug recently only, where some of the code that was working on local or using these tools did not bundle up correctly, and we were targeting some newer browsers, and in the older browser we forgot to include some polyfill which did not show up in the newer current browsers, and the system was kaput. So we were trying to think like how can we solve for that, and then we found out okay, let's stick to one thing. And I think that was the earlier reasons when this HMR came into picture, that people did not want to use this, because the way HMR worked previously, I think 2016-17 was different when your app was bundled, because it was changing hot reloading your state, and also it was difficult to debug state problems locally than in the production server. I remember that stuff too. So yeah, that was what
Definitely,
is
but
keeping me
I think
from jumping onto that train.
Yeah, I think Wheat's main selling point is that it'll make sure that whatever runs on your developer runs on its production build also. I mean, it'll always make sure that if it's running on your developer instance, the production build also will be clean. At least that's their one of their selling points. That's how.
Sure.
Yeah.
I guess we'll not take any more spoilers from your talk, Pavitra. Actually, I have a follow-up question for all of you. Like as Pavitra mentioned, that these bundlers are not written in JavaScript. I have previously contributed to um I've previously contributed to a few of these bundlers, and the main reason for the ease of that contribution was because they were written in the language that I was using at my job. Now, since this ease barrier is changing, what do you guys think? Like, will the open source community still be so iterative on this, or will there be a higher cost to enter the contribution graph of these projects? Rahul, Ankit, Pavitra, any views?
No, I kind of get where you're coming from because I've also contributed to Rollup, and it was way significantly easier for me to do than to do in ESBuild, which is written in Go, which I have clearly very little idea. But then there are so if you use just one language, right, then there are so many features that you don't even think. So in JavaScript, since we are used to event-driven single-threaded model, we don't know how concurrency actually works, right, which is one of the basic tenets in backend development. So any backend engineer would know how concurrency works, how to take thread logs, what semaphore is, right? So I was thinking that it is not a bad idea to maybe learn that and add that skill to your portfolio, that you do this, because patterns are mostly common at these places, just one or two things. So that's what I think. I mean, it's good that different languages are coming up. I mean, there's more to learn now.
Want to add one more thing on top of it. While ESBuild is written in Go, there are other plugins that are still written in JavaScript. So you can still go ahead and create your own plugin, contribute to them. So still, open source community is not disturbed around that. Yes, the main part is in ESBuild, that is in Go. Yeah, that might over community will be hampered around that. Yes.
That's a
I
great
feel
point.
like JavaScript is a more difficult language than Go to learn, to be honest. It might be, and also like community engagement graph, if you see on who commits and stuff, you will see that only one or two people really make like huge contributions to open source libraries. I don't know how this will pan out, but I think like ESBuild will remain as a core and under the maintainer's care. He's a founder of Figma, I think. Yeah, and
Okay.
he's written a lot of documentation, which could help like contributors if they're really motivated.
I totally agree with you on the open source being written by a very few people. You should look at the issues. This is not working for me. Please fix it. So I think there is a greater need for people to be responsible and come up. Because if you see, I was just checking ESBuilds. So if you have made only 5 or 6 commits, then you will be under top 10 developers who contributed. So yeah. And on the same note, I'm also looking for maintainers for my open source project in Finite React scroll component. So please come on and triage the issues and help me.
There you go, people. Plugs and opportunities for
Shameless
everyone
plugger.
but this is an opportunity for people who are trying to get into open source. All right, moving on. This was about developer experience. Moving on, we have a question from one of the people who submitted. This is, if you have to choose only one technique to improve performance, what would that be? Starting with you, Rahul.
If I had to choose one, that would be preloading with being mindful about HTTP caching. In my opinion, preloading is the best thing that has happened with browsers. So yeah, if only one thing, preloading. Other than if you have more things to do, try to add pre-caching as well. Pre-cache all of your assets as early as you can.
And when you say pre-cache, are you saying like deploying techniques using service workers and other stuff?
Yes.
Okay.
Yeah, mainly using service workers. Yes.
Okay. What about you, Ankit?
Okay, I heard this word service worker, but I'm not sure whether I'll ever know service workers enough to be so much confident that I don't bork it at all. So if you're using service workers just for your static assets, do not use service workers. I mean, service workers are way too powerful. I will tell you what it can do in just a bit if I get time. But if you are looking for static assets, you should cache control headers is your friend. I've been using this since 2015. If you have static URLs like CSS and your JS assets, fingerprint them, keep a good hash, and never I mean, make the public max age to unlimited time, like 1 year, so that they never expire. So that the request from browser never asks the server whether this is old or not. So you save one of that round trip, and if you have 5, 6 assets, that saves you 6 to 12 round trips. And I think everybody knows this, but I still get very excited talking about cache control public headers. But make sure that you don't enable that on dev, otherwise your local dev package will never get updated and you won't see your updated code.
Well, some of us have definitely wasted hours there, but yeah. Moving to Pavitra.
Yeah, for me, at least from my experience, is to focus on the critical path of any experience, be it your first load, be it any particular interaction. To focus on that whole path is has been very beneficial. The amount of like crap that the excess data and excess code that we put into that critical path is one of the biggest culprits. Like if you go and make it as lean as possible, only load whatever you need, make that bundle smaller. Even uh, it's not completely dependent on bundle size also. It is the amount of code that you have your browser has to run to get to that experience being good for your user. uh, yeah, having second, third, fourth looks at that uh, can give you a lot of benefit in my experience.
Yeah, like the cost of transaction, like every
Prateek.
click and every. Right. Ankit, you were saying something?
Okay. Yeah, I was saying before you move on to the next question, I wanted to ask in this caching, right? I want to know like when can we have domain, like let's say you download React on one of your apps, abc.com. If I'm using the same CDN URL, can I use the same? Can that be cached from def.com? Like across domain, when can
Yes.
we? Since you work in Google, you should be able to tell us this answer because I don't know.
Right. I can tell you that there are discussions. So for a very long time, we all have used jQuery in this way, where we use jQuery from one CDN, and all the websites that used the same URL just basically got it for free. That it was downloaded and used from the client's browser itself. The problem where what caused this to not work anymore was double key caching. When you are able to share a single resource, you are able to that shared URL was able to get information from other domains. That's why double key caching was introduced in all the browsers, and if I'm not wrong, it's already working for Safari, for Chrome, and all the major browsers. However, the need of this was very clear, and there is a proposal which is already being worked. I have completely forgot the name of the proposal, but yes, like there's a discussion going on how we can enable this again for React. I can probably dig up the link and try to see if I can find more. I can find more information on this. But yeah, like for all these queries, I probably just go and tag Google Chrome devs. They have way more latest info than a single person could ever comprehend. Okay. It seems like we've lost Ankit's video. Ankit, are you at least on audio? Nope. Let's hope we get Ankit back. Yeah, but till then, we can at least start with the next question. My next question is actually for Rahul. Rahul, I know you work with a consumer platform
Yes.
product, right, at Swiggy. And a recent set of metrics known as Core Web Vitals was recently introduced, right? I was wondering if you guys use Core Web Vitals to track these metrics, or like how do you track these numbers? How do you track these three core metrics that was introduced, if at all you use them? Otherwise, we need
Yeah,
to
we
find
actually have
another one.
started using this recently when Google Search Console added into the reporting, and mainly we are using because Google is going to add into the SEO ranking. That's the main reason that we'll be now uh, keep tracking about our core web vitals numbers. Yes. So yeah, we have alerting and all of those mechanisms with us right now.
So the question that I would want to ask you is like, how do you track these numbers? Do you use a library? Do you use the library given by the Google Chrome Dev org on GitHub? Do you use a tool which already does this for you? I
So
know Next.js also has this thing where it can automatically track this for you.
yeah, we're not using Next.js, so won't comment on that part. But yeah, for at Swiggy's purpose, we are using mainly two tools. One is SpeedCup. It has already started reporting core web vitals, and you can add alerts on top of it. And we are using Google Search Console. So yeah, these two tools we are using it in our weekly scrums. Yeah.
Okay, cool. That's
Okay,
yeah, that's
Prateek,
interesting.
I heard you saying about Next.js, and since I know for a fact that you have contributed a great deal there, could you shed some light? Question to the moderator.
Sure. That's actually one of the most interesting things, and that was tracking core web vitals with Next.js was one of the first contributions that I did to Next.js. So that is really close and dear to my heart. But the thing is, they basically have an API there where you, in the main app.js file, you export just a function with a particular name to it. The name is a reserved name. So you just declare a function, and what Next.js does is it basically feeds those values to that function. Now, when you get the core web vitals name of the metric and the value of the metric, and then it's up to the user. They can send it to their Google Analytics. They can send it to their ingestion pipeline. They can send, basically it's a backend agnostic implementation, and the developer can basically send it wherever they want and do all kind of analytics to it.
Cool. I think I'll make a mental note to look at the implementation and add it to my app, and then define that as a KRA on my next performance review.
Sure. Okay, cool. Core Web Vitals have been a great contribution to the loading metrics, and they have benefited a lot to the consumer side apps. I wanted to know, like, what kind of performance analysis do teams do who are working on long running apps. So not all apps are transactional. For example, e-commerce apps, you go, you find, you add it to the cart and you get away from it, versus other kind of apps are basically looking at dashboards. These apps are open for a very long time on your browsers. So Core Web Vitals might not suffice all the needs here. Wondering if you guys have any insights on how do what kind of perf analysis do you do for these kind of apps beyond load metrics? How fast my page loaded?
So we once had a 20% time project where a bunch of us like sat together and looked at our DOM size and looked at like how much HTML, how many HTML nodes we had. It was quite a lot, and we tried to reduce it uh, without causing regression. So that was one effort at least. But I don't know of any industry tools that actually help you with memory analysis over a long time. Definitely over. So I work on Jira. So for a long time now, we've been focusing on the first load and interaction performance. But we have realized that we do consume a lot of memory and RAM when it is in different browsers. So this is still very nascent for us, but yeah, that is the next thing that our teams are looking to focus on based on performance, because it is a long running app. People keep it open all the time, and they want to share it, especially on they keep it open on, like, we used to have it open on large TVs and stuff. uh, yeah, definitely something that I'd like to learn about.
Okay, cool. Actually, so I have a follow-up question here, and also a comment from one of the viewers. The direct question is actually, is Redux slow for huge application? But let me like just rephrase this. Like when you have a centralized data store to which everything is to which literally everything is going, and the app is running for 30, 40, or even like 30, 40 minutes or multiple hours, do you think this could grow to a size where memory becomes an issue? Or have any one of you ever ran into such memory issues?
I can kind of talk about it, because we moved away from Redux to using more granular stores. But there is a risk with these also. What I have found, that while it is much better developer experience wise, we can have a lot of these stores around in our app, like floating around in our app. And it's now, after like a year or two, no, year and a half of usage of outside of Redux, at least in Redux you know that this is the only store that can remain, right? But outside, when we are using these granular stores, they have kind of exploded. And I don't know if it is more memory efficient than using Redux, from that, only from that angle. But in all other ways it is much better than Redux. Like, you can code split better, you can yeah, you can understand your app better, you can share state better. But memory and performance wise, memory wise at least, I don't know if it is an advantage, because
Okay,
you
do
are
you have?
storing the same amount of data, right?
Sure. Sorry, sorry
That's
to
what I
cut you
was
in.
about to say. That am I audible?
Yep.
Okay. So full confession, I am a Redux fan here. So I don't think if you have a single store, it is the evil. And probably what I'm thinking is that the subscriptions that you are taking out of that Redux store, maybe that's not correct. That your every component is re-rendering whenever any slice of that Redux is changing, and maybe then your nodes are not getting garbage collected because you are keep on having those older nodes. So that might increase your HTML nodes and memory. Because let's say, to dumb it down, if you have the same data, right? So whether you keep that, let's say you are measuring the data size in kgs. So if you have 5 kg data, and whether you have one store of 5 kg or 5 stores of 1 kg, it still remains the same. So most probably it is about your memory leaks in the app. You should do a heap analysis, and when you find out how to do memory leaks, how do you determine memory leaks which is causing, you tell me also, because that's something that I'm not very good at. I've tried multiple times, so it's difficult to find memory leaks in your app. uh, but I think if you write unit test, React testing library would show you that you might probably have a leak here because you are missing a subscription, you have used something on use effect, you have not cancelled it, and so on and so forth. So Redux is awesome, at least I feel that.
Okay, cool. Good points and notes from there. My next question is a bit is not directly related to code, but how do you talk to leadership? So we know, like, having worked on e-commerce and a few other consumer-facing apps, you know that there's competition. People are jumping from your product to any other website or any other apps. So you know that you have to be on top of your performance analysis and performance numbers. But what do you do if you are an enterprise solution? What do you do if you are like a B2B app, like where, for example, let's say Jira, or even say, I've with Google, I've worked with the Google admin the Google Console for enterprise. So like
Cloud console.
when right. So users have already bought into these products and they have nowhere to go. So how do you convince your leadership that performance is still necessary while your users are not showing obvious signs of leaving the product? But performance is still necessary for these. As developers, we understand this, but how do you guys communicate to your leadership, or how do you guys help your teams understand that performance is still a necessary pillar for building these kind of web apps? Any takers?
I can go.
Sure.
So, like Prateek said, right, that these are enterprise applications, and I'll go one level deeper. So, enterprise applications, like Prateek said, if you've bought in, you have that subscription for, let's say, in a year, right? After that, you still will leave. But consider the case where I'm taking Rahul's example, Swiggy or Flipkart, right? You have so many delivery hubs, you have warehouses, and there are some applications that are needed there for your food to be picked up or for your stuff to move around, right? And then these are employees that are hired by these organizations, so then they are logged in for their tenure, right? As long as they are in that company, they have no choice but to use that tools. So then that could make the developers or in the engineers very reliant. Okay, we control the audience, we control the browsers, we control the devices. But there is one simple example. What happened was there was some code that we pushed out and it caused huge lags, right? So it is the example is of Shimla. There was a loading unit, a docking unit, a hub where trucks were coming in to unload the items. And since there was a lag, the queue started building up, and then there was a traffic jam at highway for quite some time just because of slowness in the application that we were not able to unload stuff properly. So I think it's very important for engineers of every application to take performance as a feature. And yeah, I can't stress that enough because these are tracked, and have little empathy for the users, because the people who are using your app might not be that tech savvy. So for him to know that pull down is refresh and all that, I mean, uh, take into account these small little things and make your app refresh proof, please. If you control the audience and if you have so much power of your over your audience, make it refresh proof, and he should land where he was even if the device crashes or he refreshes. So yeah, it's true story. I'm not fabricating.
That's a really nice story, and yeah, like productivity still gets hampered, no matter
Right,
if you
productivity
are.
is the word.
Cool. Pavitra, you were saying.
Yeah, so for a long time, for us, we have known that performance is really important and our users really want it. But there was, I think, for a long time, a misconception that if you have great developers, performance will come as a byproduct of your development. But what I found is that is not the case. So that is what you need to convince leadership of. Not that everyone knows performance is important. They use it if they use it every day and it's slow, like if your stand up is slow, then people get pissed. And but what to do about it is what you have to convince leadership. So in our case, at least, we were able to convince that performance has to be OKR for the team. Otherwise, it will not get done. It will always be sidelined, because performance is not just when you work on the app. Performance is measuring. Performance is testing before you send it to production. And performance, even though the whole industry is all gung ho about performance, the tools are really lacking, if you ask me. Like when you merge code, can you tell that whether that code will regress performance or not? I don't think there is any definitive way of saying that until now. Only real user monitoring kind of tells you if there is a regression for your users. It depends on what data is being used, what configuration the user has, and stuff also, right? So convincing leadership that it needs to be its own feature, like Ankit said, that performance has to be a feature, that a significant amount of talent has to go into looking at performance alone, at least for some time, before the culture gets embedded in the org. That is, I think, what people find hard. It's if you leave performance to individual developers, or anything for that matter, if you ask me, like testing or any typing, whatever, right? The developer will focus on delivery and not yeah it's like, with your time, what will you do, right? So performance has to be a priority for the development team, preferably if you have the budget, its own track, or at least if you don't have, you need to have performance sprints and stuff to continuously improve performance. I feel unless you focus specifically on it, it's not going to improve itself.
Cool.
True.
Awesome. So while we are talking about convincing leadership and talking about performance, has this ever happened to you that you went in and over optimized something, or eagerly or optimized your performance, which has actually hurt you back? Well, do you have any insights for the developers here?
Yeah, I can pitch in. That happened with us quite recently with our product Swiggy Super, which got revamped few weeks back. We have a preconceived notion that SSR will solve all our problems. SSR will result in fast print times and things like that. But it ended up having a flash of white screen. Why? Because one of the downstream APIs took approximately 1 second, which led to a lot of, like, quite some time around white screen. Uh, Plus, we ended up doing a lot of preloads of our fonts, of our images, which were not required at that moment. So yeah, those were the over optimization theories that we had.
What kind of advice do you have for watching these kind of over optimizations? Does someone really should wait until they run into it, or are there like bare minimums that one should do and just stick to it?
So I would say ship it. Let's ship it first. If you don't have like, try to convince your management or your team to have a canary deployment setup where you can at least deploy to certain set of users, maybe it's an internal organization or to a certain set of public user, and start monitoring on top of it. While these are new features, you can set your budget on top of it and keep optimizing over on it. Like, instead of, okay, we'll do everything on day one. So mainly two things. Have a canary deployment at your place. Try to ship it as early as possible.
Okay.
Yeah,
Cool.
my advice would be, don't optimize without measuring. Unless you know it is really slow, what is really slow, there's no need for optimization until then.
I was
Sure.
bitten even after knowing that it is faulty. So I was writing some tests, and then I saw that I told you, right, React testing library would give you that these components are still doing something after the tests have ended. That means that there's some leak. So I found out that some component was setting state even after it was unmounting. So I went ahead and I added a check called, if it is not mounted, don't call this. What happened was that the condition that I put in removed some loaders from being hidden. So loaders were shown, and then when the app went into production, some users were seeing like loaders, fake loaders onto it, and they were trying to fix, which API is slow, where is the issue. But then, since I was the culprit, I knew what the problem was and presented an RC. So yeah, it's both ways.
Sure. RCAs about over optimizations are one of the most interesting ones. Okay, cool. I see we don't have a lot of time on our hand. We have this one question from our Slido, that what would be the things to do in CRA to optimize perf, assuming you can't switch to Next or Gatsby?
Eject.
Okay.
Like, even if you
No,
eject,
I
what will
was
you
just
do after
kidding.
that?
I have no, this was not a real answer. I was just kidding.
I would take this. So if you can't switch to Next.js, maybe you can take an inspiration of what these guys are doing, what Next.js is doing, what Gatsby is doing, what all things they are doing. Things like preloading, what which is what's their image lazy loading, code splitting, things like that. You can take an inspiration from them and start building into your app, CRA app.
Okay. Now you're cutting out a little bit.
Am I audible?
Yes, better now.
What was the last thing that you heard?
Yeah, we heard that. Let's take inspiration from Next.js if you cannot if you cannot just switch to Next or Gatsby.
Yeah. So I was talking about take inspiration from them, look at what things they are doing, preloading, uh, asset caching, then image lazy loading, code splitting. You can all do all of those things in CRA, one way or another.
So code splitting is one thing, but then loading of those chunks is another. I think everybody uses React.lazy and Suspense, but then if you render that directly in your render without any condition, then it loads eagerly. So even if you've splitted that chunk up, so you should make sure that you load it only when it is required, maybe on click of a button or something route transition. So using just React.lazy does not fix all of your problems. So yeah.
Okay, great point. Yeah, actually, I can myself add a point here just to start off. If you are starting off a new project or anything, there is this one collaboration that we did with the React team. I'm not super sure whose idea was it, but the React docs or the Create React App docs now clearly say that Create React App is not for highly scaled productionized app. Create React App was a project that started to make it easy for everyone to get started on React. You don't have to deal with Webpack. You don't have to deal with any other boilerplate or any other setup code. You can just get your hands dirty with React. Of late, we have seen people taking this and deploying it for their production apps. There are a bunch of primitives that are missing there. For example, as we discussed, like out of the box code splitting, then lazy loading, what kind of loading sequence should be there. So, if at all you are starting with a production app, I highly, highly recommend that you should either get started with Next or Gatsby, both these tools, or any other React starter tool built for production apps. All these frameworks have a baseline KRA that it should be easy for developers to get started. And if that's not the case, they should know about it. But till the time you are trying to play with React, get your hands dirty with React, it's all good. But do not build your scale productionized app with Create React App.
Or any boilerplate for that matter.
Yeah,
Or
wet
if
your
you're not
boilerplate
looking
code.
for web
Yes.
performance.
Yes.
All right. This would be the last question. We have 2 minutes left. So once, if your team has fixed the performance problems in hand, how do you basically get them to own the performance culture, or how do you get that performance culture set in your organization? I've seen cases in places that I've worked, in teams that I've worked. Once the most biggest perf problems are solved, everyone is back to square one, not bothering about it, being complacent about performance. Like, so how can someone or a team make sure that performance is deep rooted in their organization, or at least in their org of the company, so that these things don't come up again and again? Any views on that?
Yeah, definitely. Like spreading performance culture is really hard. It took like our team at least 1 year, uh, uh, after which like even leadership understood what exactly TTI or FMP and all of those things meant, and they were using it in their updates and stuff. So that was a really proud moment for us. But again, yeah, you need like great measurement, and we have an org level now dashboard that tracks major experiences and loading times. So even like a 30-40 millisecond drop in that is noticeable to everybody. We have still not added those alerts for our on call. We are almost there, but it feels a little harsh. We are focusing on finding these things out in pre-production as not in production. But yeah, at least we have been treating performance regressions as production bugs. So we treat it as Sev 3 hot, and kind of work on it that way. So that way you can get more people to focus on it, and people will be motivated not to have a hot performance hot in this thing. At least these are some techniques that we are using. Make it a production bug, and you'll get more people to care about it, is what we've seen.
I really need to ask this. If Jira's production performance goes down, is there a Jira bug automatically, a Jira ticket automatically created for it?
Yeah.
Awesome.
Yeah,
On
yeah,
point.
yeah.
That would be
Standing
epic.
Ops Genie call and a Jira ticket is created.
Okay.
And
That's
the
branding
Slack
on
room
point.
gets created and people
One more point.
get called.
Yes, Ankit.
One more point to what Pavitra said. So Pavitra talked about measuring these parameters, TTI, time to interactive, time to first paint, right? I feel that these are just the tip of the iceberg, right? But let's say once you go onto the client side of the page, let's say you're shopping on Flipkart, you enter, you want to filter by brands, you want to buy shoes, right? And then there's a big brand filter and there's so many brands. On typing of that, right, if you do not get that response within 100 milliseconds, right, if the UI does not feel snappy, that I'm not sure how to single out those performance issues unless until you are doing manual testing. So they don't get caught up. I'm not sure when should an engineer go to his dev tools and profile that app. Maybe E2E integration tests would increase time, but if you are adding integration tests daily, then that time also gets increased. So there is always a moving target. So this is one area which I need some help in, like how are people doing it? What should be done?
That is a design system concern, though, right? Like, I know you might not have a design system team separately, but we treat it as a design system concern when one particular component or part of it is not working very well, is slow to interact and stuff. That will become a design system priority for in our book at least. So yeah, finding the owners for all these things is important. Yeah.
Right. So even in the audience,
Ankit,
if
I want to
somebody
add
has
one
an
thing here.
answer. Yeah, sure. Sorry.
So one thing I want to add over here, like on production, when something goes wrong, when something is janky, how do you fix that? The answer to that is your developers, right? Like your developers need to be empowered towards performance. That's the ultimate goal that we should head for. If your developers are not empowered, things will go for a toss. They'll end up shipping only the features. That's it. Like they won't even care about, okay, my animations are at 60 FPS, is it janky or not? So culture is an important part of it. Developers need to have empathy towards user. They should be empowered towards performance.
When we say empowered, do you mean better tools or do you mean better processes or both?
Better processes, you should have an alignment with a stakeholder that, okay, even having a small the long load time can affect our business. All of these ecosystems I'm talking about.
So my problem is, let's say I am assuming that there is no fault of engineers. Engineers are super motivated to do this thing, but mostly what happens is the set of data that you work on in your development environment, right, might not be a full production system. You might only get 3 brands while you are testing your system, and in production there can be like 200. So that's the difference. So they would never find out in their test data that there is a problem.
That's where
I think I've
real user
spoken too
monitoring
much.
comes into the picture, right? So that's what I'm talking about. If a developer is empowered towards it, he'll actually go and use those tools for their own benefit and
Okay.
ultimately company's benefit. Yes.
Yeah, that makes total sense. A bit of process and a lot of tools to get these automated for you. All right, guys, we are on time, and I guess this is where we say goodbye to the viewers. We'll be hanging out for a session for next few minutes. So yeah, keep your questions coming. Thank you.
Bye bye, everybody.
That was an amazing panel discussion. Thank you so much, folks. Thank you so much to all the panelists and the moderator, Prateek. That was a very insightful discussion. I thought that the discussion couldn't get better with all of that information, all of the really good points that we talked about web performance. But then I think Prateek brought up the topic about web performance and like how to inculcate the culture of performance on an organization level. And I really love the point that Pavitra brought up, that it's all about the culture and like making the team know that there are stakes in this. And then the dashboard, the performance dashboard that they use in their organization. And then Rahul talked about empathy towards the users. And I think these are all really good points that all help us really understand why web performance matters, and not only on an individual basis when we're working on side projects or hobby projects, but when we are as developers, when we're building something bigger than us, right? So these are the things that would really help all of our viewers. And that was an amazing panel discussion. Thank you so much, all of you folks, for your time. That was the last session of today. All of our panelists and the moderator, they will be hanging out in their sessions tab, where you can interact with them, connect with them, ask them some more questions if you have. So make sure that you drop by the sessions tab and get in touch with them. Finally, I would like to conclude day one of React Day Bangalore. It was an amazing day. Thank you so much for joining us. I would like to give a quick shout out to our sponsors and our partners. This conference couldn't be possible without them. So thank you so much to all of our partners, to all of our sponsors, for helping us make this event successful. Yeah. Thank you so much to all of our sponsors, Archimedes, Atlantis, Auth0, ClearTax, Geeky Ads, GoIBibo, Grow, Harness, Hasura, Disney Hotstar, Open House, Column, Razorpay, Swiggy, and Exactly. This event couldn't have been successful without their help, so big shout out to them. And finally, let's take a quick look at the schedule for tomorrow, day 2. So we will be kickstarting day 2 at 10 a.m. IST tomorrow with our first talk by Pavitra Kodman on next generation front-end tooling. And then we have a bunch of other talks, a few breaks, and also 2 really interesting panel discussions, again, just like today. And we will be finally concluding our conference with a panel discussion on finding your first job, moderated by Kamlesh Chandani at 5 p.m. tomorrow. So thank you so much for joining us today. We would love to see you all tomorrow too. Until then, take care. Bye, everyone.